Good morning, everybody. We're just going to let everybody join in here. Just going to give a few more minutes, probably wait till about 2 minutes after the hour here just to let everybody join in. Kind of booting up my Peplink University in control because today we're going to finish up the module 2 and we're going to go into module 3, which is going to be in control, UI, and speed fusion. So I'm spinning up my Peplink University in control. I've got my Speed Fusion Renegade with my HD4 connected. I'm booting up my backpack right now. And so that's going to come online here in just a minute. We'll do some UI training as well as Speed Fusion discussions and things like that using my Speed Fusion backpack, which is sitting behind me. So it should be a really fun day here. Kind of going through this. Module 3 is when it starts to get really, really fun. And then module 4, we're going to do troubleshooting. Okay. I think it's good enough. We're going to get started. I see the numbers stopped increasing so much there. So my name is Peter West. Sometimes they refer to me as Professor P or Professor Peplink. And today we're working on the second session of our Peplink Certified Associate Program. And if you missed the first session, we did record it, and we will be publishing that on YouTube and sending everybody that's registered a link to that as well as the slides. Due to the 4-hour length and of the video and the need to check it, I believe it's probably going to take a little bit longer for them to release than the normal Peplink University videos. But for the most part, you will get a copy of all those. In the very first session, just as a little quick, small recap, what we did is we talked about just sort of the basic understanding of networking that we require that kind of goes into SD-WAN. So understanding IP tables and routing and subnets and making sure you know that BGP and OSPF and RIP and that Speed Fusion natively uses OSPF in our ecosystem. And then we started talking about the hardware. And so we went into the routers and the 5G devices and FirstNet devices and kind of did a hardware recap. And we showed you how to access hardware specifications at compare.peplink.com. And then we started doing some case studies after that. And so we're going to finish here on I believe, the last case study. And then we're going to go into some more hardware after this. And then we're going to go into the actual UI. And once again, my goal is not to miss. My goal is to not skip around. And so whenever I do these trainings in real life and I'm limited to an 8-hour session or 2 days with breaks and lunches and things like that, I end up having to like rush through parts. And we don't want to do that with this. We want to take the time to adequately review so that you can come back and look at this information and really feel like you have an understanding of the Peplink ecosystem and what we're doing. And so that's where we're at. I love feedback. I love questions. I understand you guys can't all talk to me, but you can ask me questions, and I will, if it's relevant to the current module, I will answer it. If it's not, I'll say, hey, ask me this again in module 4, or ask me this in module 3. So I'll tell you when to ask me again. But because I do want to stay on topic without getting distracted, but at the same time, make sure that we have as much fun interacting. Someone did ask if there's a quiz for part 1. I honestly don't know. I will tell you how to take the tests at the very end of this, but whether or not Peplink is sending out quizzes, I don't know. And then Travis is not here today, so I'm going solo. Hopefully he'll catch us on the next one. And so I think he's traveling for work. And so I'm running this one. This one's slow. So if I don't get all the questions, I do apologize. But I'm going to dive right into this, and I'm so happy everybody's on this, and how many people want to learn about Peplink. And so this particular part of the project is actually about selecting the right hardware. So we just reviewed all the hardware. We talked about the balance routers and the max routers and the different routers we have, and so now we talk about selecting the right router, why we select a particular router, and one of the case studies that we have is an SD-WAN deployment to replace MPLS and network equipment for a really large construction company. And the challenge with this was we needed to have high density branch offices. So branch offices with lots of users, construction sites, and remote work like field sites. And so we had a whole bunch of different sites with different needs, different number of people in those needs. And so we built a pretty, let's see if there's an image to this or not. Give me 1 second. Yeah, we did. Okay. So we built a three-tiered system when we quoted this out. And what we did is we basically created a tier 1 site, a tier 2 site, and a tier 3 site. So tier 1 sites were kind of our uh, larger branch sites or headquarter sites where they needed high availability, dual ISP, dual fiber, et cetera. And they're going to have a lot of users, anywhere between 200 and, and 300 or 400 users. And we wanted to make sure we built a site for that. And then we had like our small field sites where they might have, 10 to 30 users, and maybe have one internet connection with a 4G or 5G backup. And then we had field sites or like construction sites where maybe they had no internet, maybe they had Wi-Fi internet, or they had a cable modem. And so it's really an unknown internet. And then, running the project itself. So usually a handful of project managers and GCs and things like that. But, probably around less than 10 people on the site that really are going to be using data. And so the engineering side of this took a long time, and we ended up standardizing with the SDX and HA mode at all their head-end sites. We built transit kits for their field site, for field site or for construction sites, and then we used my brain just farted, HD2s for dual internet sites. And so and they've actually recently just upgraded to 2500 ECs and 5G and BR2 Pros. So this is sort of an ongoing development. But the idea behind it is the SDX played a critical role because of the modularity. And so when you're talking about fiber, like handoffs from the ISPs, sometimes it'd be a fiber handoff, sometimes it'd be an Ethernet handoff, sometimes they were getting a gig circuit. And so they wanted to make sure they had modularity and the capability to have different internet connections, or even plug a 5G modem right into it, which we actually did a few times as that second internet connection. And so the SDX created that modularity. It supported the users that they needed, and it has that 600 megabits of bonding throughput that really allowed them to operate remotely. And like I said, since then we've actually upgraded some of these more recently. But the point behind it is picking the routers to scale based on the use case and the budget and the needs they had. And it was a lot of fun to choose. Travis isn't here, so I can't talk about this particular one. That wasn't mine. I apologize. So I'm just going to skip that one today. The next section here, after we talk about the hardware, is going into our ecosystem. And so talking about the SD switches, the APs, the SIM injector, and our antenna. So completing our ecosystem. And I'm kind of coining a term, and we'll see how well it takes on. But when we talk about SD-WAN and we're trying to compete with like some of the other carrier providers out there, a lot of these guys are handing multi-WAN connectivity to an existing infrastructure. And so they're really bridging sites, and it's SD-WAN has become this MPLS replacement, and that the carriers are basically trying to keep hold of their contracts. And so they're offering SD-WAN services, but really they're just wrapping this around MPLS and trying to maintain those contracts. And Peplink is so much more than that. We have an entire ecosystem. This software defined infrastructure is what I'm kind of playing around with right now. But the idea is that it's not just the WAN. It's our VLANs and our LANs and our intersite connectivity. It's not just load balancing multiple internet connections together and creating a VPN between our sites. We're aggregating that data. We're creating layer 2 and layer 3 tunnels between sites. And then we're extending this into the LAN. So we're saying, hey, let's take this idea and move it to the LAN. Can we make a software-defined infrastructure and make it super easy to manage your VLANs and manage tens or hundreds of switches without having to do a whole bunch of manual coding, and having features like DHCP trusted and untrusted, or snooping, or 802.1x and things like that. And so Peplink brought in the APs first, and then they brought in the switches, and I really like the switches, especially when you tie them into end control, and I'll show you some of this later. And so we have 2 switch categories, 5 total switches. We have the SD switch rugged and then the SD switch enterprise categories. And so the rugged switches are really neat because they have dual um, DC power input, so 54-volt blocks, no fans, no moving parts inside, and a really massive heat sink. These things are not light. If anybody's ever played with these switches, I mean, they are beefy. The 8 and the 16 port, all of them have PoE plus support. The 8 port is 8 ports of PoE plus. The 16 port is 8 ports of PoE plus and 8 ports not. And then the 16 port has LAN bypass. And I talked about LAN bypass when I talked about the balanced routers. And I actually have a YouTube video on the 16 port switch for LAN bypass. And the best way I can say is imagine you have a train and you have 3 cars. Let's say you have 5 cars actually, because it'd be cooler sounding. And you have 2 Starlinks at either end of the train, and then you have 16 port switches with LAN bypass, and we connect them all together. If cart 3, the middle cart, power fails, the switch goes off, the connection is still made because of LAN bypass. So the network is still functioning. Even though that cart loses PoE and they lose internet in that cart, the cables connecting the carts are still good and will still function. So LAN bypass connects the cables like a jumper cable in the event that the power is lost to the router. And so the 16 port switch has this built in. It's really cool. I did a demo where I unplugged the switch and maintained a VoIP phone call while doing it. And that's on our YouTube channel. And then the 24 port is 24 ports of PoE, and then it has 2 10 gigabit SFPs. The 8 and the 16 have 1 gigabit SFPs. And once again, this fanless, ruggedized design with high temperature capabilities and variable power inputs. Then we have our enterprise switches, and these are kind of cool. These are triple power supply, dual power input. How often do you have 2 power inputs going into a switch, and then your UPS fails, or you have an outage of that one power, and you lose half your PoE budget? Peplink was like, I don't want to lose half my budget. I want dual. I want redundant, unbreakable power, just like the rest of our ecosystem. And so there's 2 power inputs that power 3 power supplies. So you can run, if you only have 1 UPS, you only need 1 power input. If you have 2 UPSs, you can do 2 power inputs. And then you have these 3 power supplies that work regardless of the number of inputs you have. And then if you lose a power supply, you still have your full PoE budget. You have to lose 2 power supplies before you lose your PoE budget. And that's really cool. So we have 3 redundant power supplies, 2 power inputs, a 50-watt system budget and a 100-watt system budget, 24 and 48, and then 800 plus watts of PoE power. And so you're getting incredible versatility and capability on our enterprise switches. And sort of what I just said here, but redundant power source, PoE plus ready, 10 gigabit ports on the 24 and 48 port switches, and then our intelligent power management detects power consumption, delivers the needed amount, and power consumption is reported and in control. And then if you take the routers, the switches, and the APs, our Fusion Hub and the cloud, you can wrap this around our in control management. So the switches and the routers are all managed and in control. And a lot of times, people talk about like core switch stacks and things like that. They do have their relevant place, but in the SMB or kind of the medium and enterprise, some of the cloud focused enterprise space, even that's becoming less of an issue. And so what we're really passing on, what Peplink does really neat, is when you pair our routers like the SDX, the SDX Pro, the EPX with our switches, you're extending that software defined architecture throughout your environment. And then we centrally manage that in control. And so it's kind of a neat way to think about networking that really simplifies the architecture and allows for incredible scalability on the access switch level. The switches also kind of bring in that UI that the balance routers have become so successful at, which making it really easy to manage. There's not a lot of complex CLI and things like that. Everything's going to be GUI based, either in control or local. And so once again, they're not required of the cloud, and that's a really neat thing. Yes, this session is being recorded and will be delivered. And so it allows you to see everything and manage it, and I'll kind of give you guys a little tour of the switches. And in control, you get even increased visibility, and you can see kind of this is the in control UI versus the switch local UI. You can kind of see all your VLANs that are applied to that switch. We can see how long it's been online, and you can see the status of the switch ports and then the devices and the clients that are on that switch port. One of the things that Peplink or the In Control brings really nicely to the table is our reporting. And so we have incredible client reporting, which I'll show you guys when I do my In Control demo, as well as configuration backup and restores, firmware management, and PoE on-off scheduling. So you can turn off PoE ports based on a schedule, which is really cool. Very similar to like using scheduling for Wi-Fi, which once again, we'll talk about scheduling when we do In Control. But the idea is you could say, hey, these switch ports are active from 7 a.m. to 6 p.m. Most attacks happen outside of that. So if you have a device that is on the network and shouldn't be on the network, or they shouldn't be available, you can actually turn these ports off. You can turn the PoE off and shut off those Wi-Fi access points or phones and things like that as necessary. So it's kind of cool. And then from the switches, we have our AP series management. When we talk about our AP series management, everybody's asking really good questions. We're going to talk about most of this in module 3. So right now it's reviewing the hardware. And so I'm not ignoring your questions. It's going to be more of a module 3 thing, which is coming next. Unifying the Peplink ecosystem. So we have our AP series management. And so this is where we take the hardware, take the router, we take the internet, we extend our infrastructure on the LAN side, and then we now bring in our APs. And so now we're talking about wireless access, going to their switches, which gives us kind of unified VLAN management. So you can create multiple SSIDs with VLANs and captive portals, and all that's being very simply deployed throughout your ecosystem from In Control 2. And so, and once again, this will be almost a broken record here, but you can manage all of our devices locally, or you can manage them in the cloud. So we're not cloud required, we're cloud optimized, if that makes sense. And so locally on the router, you can turn on AP management. You can set your the APs that you're approving, or you can just say any, and then you can actually turn your router into an AP controller. And when you do that, you can set up your SSIDs. Once again, most of our APs support up to 16 SSIDs these days, and set up all of your settings for staff. And then you can create open networks for guests with captive portals. And so all that's supported locally. If you see kind of this dark gray and light gray and black, that's our UI. And so what we're saying is you can manage this right on site on your router. So you have an SDX or a 310 or a BR2. You can have switches with PoE and then plug in your APs and manage all of this without any need of the cloud using those capabilities. And we'll go into that in the next module too. And you have one AP profile with multiple SSIDs. So you can create profiles for radio frequency, output power, beacon rates, beacon interval, DTIM, RTS thresholds. You really configure how that AP is functioning, and then you can apply that to multiple SSIDs very easily. And then once you enable AP management on the dashboard of your router, you're going to have visibility into that AP controller as a new feature, and you'll see your access point and how many are online and how many connected clients you have. And if you go to the AP web console, the actual access point, you'll see where it's being managed. It'll say configured by AP controller, or it'll say configured by In Control. You can apply multiple profiles to your access points right from the router. And so once again, you just go to your access points, select the access point, and you can choose your profiles. And so different APs can have different access profiles right from the router. And then we have captive portal capabilities. And the captive portal in the built in the router is a little bit more limited than the one in Control. I like the one in Control a little better, but it is there, and it kind of keeps with that and the idea that we are trying to make it cloud optimized or cloud efficient, but not cloud required. And so the captive portal capabilities are built right into the router, and you can set up access quotas and things like that. I've had a customer say, hey, how do I make sure that if I have users of a VLAN and I want to make sure that it can only use 5 GB a day, well, right here, you could create a captive portal, assign it to the VLAN and say 5,000 megabytes a day, boom. Now users get 5,000 megabytes if they're on that VLAN, or and they can't go over 5 GB. The captive portal, you can customize the logo and the context, and you can add your own strings to it, and then you can do a custom landing page. So they go on, you can say, hey, this is my guest VLAN. You get 5 GB a day, and when they hit OK, it takes them to your website, and so they can go from there. Okay, sorry. Okay. And so you can set your context and then send it out. And then once again, if someone connects to the guest network, you'll see that they can't get on the internet. They open up their internet their internet page with the captive portal. They hit agree, and then they'll be able to sign in. Our APs also support a couple different modes. We support meshing with our APs now. So if you have a balanced 20x with the Wi-Fi 6 built in, you can take the AXAP and you can mesh it with your 20x and then extend your wireless coverage up to 3 hops. So meshing supports up to 3 hops. Every mesh relay does add a decrease in total throughput. Also, when you're meshing and broadcasting Wi-Fi on the same channels, it also offers a decrease in capacity. So if you only have 100 meg internet, you won't notice the difference. But if you're running gigabit internet and then you're trying to get gigabit 3 hops out on a mesh network, you might notice you will notice a decrease in throughput, 3 hops out. But it's a really nice way to extend your infrastructure without needing to run cables, or if you're just trying to extend wireless coverage, you could do this. And what's really neat too is if you have multiple APs, it'll find the right path and back to the root device, that 20x. And so it's a nice way to add a little resiliency as well. If you have one of our APs as well, we support air monitor support. So I don't know about you, but there's often times where I've been asked to conduct wireless performance analysis. Well, I can actually just mail somebody an AP, one of our APs, enable air monitor support, tell them to plug it into their Ethernet so it turns on with PoE, and then I can connect to their SSIDs and run performance reports right from the router. So it's almost like a laptop that we can manage and in control with air monitor capabilities. And so it's going to allow us to debug or troubleshoot networks. So the Mark asked how much the decrease per hop. It varies based on frequency and bandwidth and availability, but typically it's 50% loss per hop. And so, but not always. I've done a really good job tuning it. And then we also support DPI, which is layer 7 visibility, application visibility on our traffic. And so we enabled DPI, I believe in 8.1 firmware a while ago, and now it's on our APs as well. And it just gives us better visibility in the type of traffic that's passing through the network. Next is our SIM injector, and the SIM injector is complementary to our 4G and 5G cellular routers. And the idea of the SIM injector is to change the location of the SIM cards. Imagine I have a super yacht, which I don't, but it'd be fun if I did, and I wanted to install 5G or HD1 Dome 5G. Well, I could climb up to the top of my 75-foot mast, install my 2 domes on the top of it, and then plug in my AT&T and my T-Mobile SIM card, run Cat6 cable down the mast, and plug it into my SDX router. And great, now I've got these 2 5Gs. And then I go to the Bahamas and I want to switch SIM cards to the Bahamas. So now I got to climb up the 75-foot mast, unscrew the dome, unscrew the bottom of it, take it out, put in my Bohemian SIM card, screw it back together, mount it back, climb back down the mast. It's not efficient. It's not effective. And it makes it really difficult when you're playing around with trying to get the cellular router in an optimal location to receive signal, but also being able to manage your SIM cards as well. And so the idea with the SIM injector is I can have my HD1 domes on the top of my mast, And then nice and cozy in my IDF, my MDF, wherever my captain's chair or wherever I am, I could have a SIM injector and literally have my SIM cards there. And you can see them flashing. I can see SIM card 1 and 2 are being used and they're flashing. And I can just pop that out and put a Bohemian SIM card. The 5G dome is going to lose connection because the SIM card's gone, and it's going to reconnect to that Bohemian SIM card. And so the SIM injector allows me to put the SIM card in a more convenient location on the network. And I've done this for MBXs where the SIM cards are on the back and people don't want to stick their hands behind. So we just plug in a SIM injector, plug it into the MBX because it's PoE, turns it on. Now you have PoE, now you have SIM cards on the front of the MBX instead of on the back of the MBX. So anytime that you want to just change the location of the SIM cards, you can use the SIM injector to do that. There are 3 types of SIM injectors. The SIM injectors support most of, actually all of our 5G devices, most of our 4G devices. So it works on the 20X, the 310 5G, the 310 Fiber 5G. You can see the list here. And our Max series, MBX, MBX 5G, MBX Mini, PDX, BR1 Classic, Hardware 3. And you can see, once again, this list goes on, including the new HD Dome Pro, the big, huge long-range one. The SIM injector is a 4-port PoE plus switch with 8 SIMs capable and has 802.3 AT output. So this is really cool for environments where you want to have like an HD1 dome or an HD2 dome on outside, plug it into the SIM injector because it's being powered by PoE. Then you could have 2 APs inside, like 2 AX APs on the inside of your building, plugged right in the SIM injector. You don't even need a switch at that point. So now you've got your APs powered, your HD2 dome powered, and a SIM injector. And because it's a 4-port PoE plus switch, you have everything connected for you. And now your SIM cards can get plugged right in there. Or, and I've used this a lot for HA deployments, I have 2 SDXs, plug the 2 SDXs into the SIM injector, and then the SIM injector has PoE out, and I go up to an HD2 dome. Now I can synergize those down into the SDXs, have HA failover, and that way I don't have the 5G module in the SDX then I have to have 2 of those with antennas. Instead, I could just have one HD 5G or 2 HD 5Gs, and then go down into my SDXs. And so it's a great way to do either HA, or if you want to just have a total ecosystem on a small boat or something like that, you could do that with the SIM injector. The SIM injector Mini is powered by PoE, only a single 100 megabit Ethernet port, small form factor, lower cost, and has 8 4FF SIM cards. So the idea here is it's going to be on the LAN of your network. You have a router like an SDX or an MBX or MBX Mini or something like that. This plugs into that. And then you have either your MBX or your domes on the roof, and you're trying to just make them more simple. So the SIM injector has no relation to eSIMs. So somebody asked if I could talk about SIM injectors versus eSIMs. The SIM injector takes a physical SIM card and literally over IP puts it on the router. So it's a physical SIM card over IP. eSIMs is like a code that you're going to put in, and you actually can push profiles to the modem. Most of our 5G, if not all of our 5G routers, support eSIM capabilities. And when I do the in-control demo, I'll actually show you the eSIM capabilities. But eSIM is not SIM injector. SIM injector takes a physical SIM card and lets you plug that in. And so you can go to anywhere in the world, take the SIM card, plug into your SIM injector, and then your router is going to then read that SIM card. And so you don't have to crawl around or get behind your router to make that work. We don't want to confuse the SIM injector with the eSIM and the SIM extender. The SIM extender is literally a physical ribbon cable that just extends the 2FF, the larger of the 3 sizes, the 2FF SIM card to a different location. And so you plug it in, it has a little ribbon, you plug it in the slot, the SIM card slots on the router, and then you can extend that out to a different spot. And a lot of times people will make like a custom rack assembly with the SIM, once again, bringing the SIM cards from the back of the router to the front of the router. I find that the SIM injector is way cooler when you're talking about this, but this was a really neat thing that Peplink had released, and we use it for like the PDX and things like that. The yeah, so SIM injector is no, the SIM injector has no antennas or anything like that. It's just SIM cards going into, I think SIM cards going into, I'm trying to see if sorry, I'm walking away from you guys for a second. I'm trying to see if I have one on my desk. VR Mini, no. But the SIM injector is just going to take your physical SIM cards and move those and convert those into IP and then transfer those to your router. So there's no antennas. It's not a router. The SIM injector is simply SIM cards in a more convenient location for you. And so here you can see a slide comparing the SIM injector versus SIM injector mini versus the SIM extender. So one thing I did not mention yet is the SIM injector flex module. So now that we've talked about the SIM injector and the SIM injector mini, now we have the SIM injector flex module. So we also have the flex module, which has 56 SIM cards support, and it goes in the EPX or the SDX Pro, and it's designed for managing a lot of SIM cards and maybe a lot of devices. We have customers that have deployed 40 or more HD1 domes in different locations, and you can use the SIM injector flex module with EPX in our virtual VLAN as WAN feature. Hiccups, I apologize. VLAN as WAN feature. And basically what we do is you have your SIM injector and the SIM injector flex module in the EPX. Then you could have a 10 gigabit SFP module in your EPX, 10 gigabit to a 48 port switch, then have 40 HD1 domes plugged into your 48 port switch. And those are all WAN ports. So you just VLAN tag that. You have 40 HD1 domes all being managed with one SIM injector flex module. And so really cool for people that need incredible high throughput and demanding applications. And finally, we have our antennas. And so to complete our ecosystem, especially being a 5G and 4G company, we wanted to make sure we had an antenna profile or not profile, that was a portfolio. Sorry about that. Antenna portfolio to complement the routers. And so we've done that. There's one antenna that's missing, and I'm going to get it because it's one of my favorite antennas in the world at this point. Yeah. If you haven't heard about it or seen it yet, put this into perspective. This is the 82G antenna. Yeah, it's huge. 17 inches wide. Claims to be the most powerful 5G antenna in the world. We have an 8 5G antennas, 2 Wi-Fi and GPS, and a single flush mount or magnetic mount or surface mount capabilities and pole mount capabilities. All of our antennas are made in-house and not white labeled as of a couple of years ago, a year or two ago, when we started launching the 40Gs. And so we are but yeah, so we have a whole engineering team that makes our antennas, and the team is awesome, and they send us our antennas. But so anyways, I want to show you the 82G because it's not going to be on this because the slides were made before that. But the idea is that we have antennas to complement our router technologies, and so antennas and cabling are key to performance. And I've been doing testing, and I showed this in the last scenario or the last webinar. But my lab, and I've got 1, 2, 3, 4, 5 tables set up with a whole bunch of routers. I mean, different brand routers, different brand antennas, a whole bunch of different stuff that I play around with and try to make sure that we're testing. And the antenna is critical, and more than the antenna, the cable is even more critical. That combination really going to determine the capability of your cellular and Wi-Fi performance. And because almost everybody's sharing the same chipset, right? We're buying a Qualtek or a Sierra Wireless or, Qualcomm or somebody, we're buying some chipset, or Wi-Fi chipset, and then we're connecting it into our hardware. And so it's our software and our antennas that really make the difference. And so having good antennas makes a really important capability in your discussion on your connectivity, and we're going to talk about that. Then cables. Minimizing the length of your cables is also very important. The longer the cable, the more you have coiled up just sitting there, that's literally just loss that you're wasting on your performance. And so it's important to know the cable thickness and the loss of the attenuation and the length. You don't just go buy 30-foot cables and then coil the extra up and plug into your router. You're literally wasting all of your gain by doing that. There are some people that need 30-foot cables. That's okay if you need it, but if you don't need it, a 1 foot or a 6 foot or 15 foot, get the shortest cable length you can and run those cables, run your antennas on that. Hold on one second, I got to pile up the questions here. Yes, they're in-house. SIM injector doesn't have to have antennas. You would want antennas on the device you're ejecting to. Does the Peplink? Somebody asked if we're doing 60 gigahertz. I honestly don't know. I'd have to ask the Wi-Fi team. Does a SIM injector provide less throughput? So the SIM injector, it's not a router. There's no throughput. It's literally just taking a SIM card and pairing it with a modem. That's it. So it takes a physical SIM card, converts it into little digital signals over to the modem itself. So there's no throughput limitations. There's no antennas. It's not a router. It's just simply just a device that takes a physical SIM card and converts it into a digital signal so that the router can apply that digital signal to the cellular module. And that is the only thing it does. Bill asked if we can switch out antenna cable lengths. You can order antennas with different lengths. Most of the Peplink antennas come with a 6.5 foot length, but you can access something longer. Yes, Jerry just said it's just a token to access to the network. Yeah, it's just taking that certificate and putting it on the modem. What is Wi-Fi WAN? And we talked about this in module 1, but I'll reiterate it here. I will be very specific when I say either 5G, 4G, cellular, and then if I say the word Wi-Fi, I mean Wi-Fi, wireless 2.4 and 5 gigahertz Wi-Fi that you would use as a client and server access there, or client node access, or access point access, or whatever you want to call it. Wi-Fi WAN is the ability to use Wi-Fi as an internet source, as a client. So basically the router can be a client on a network, and then have that as an internet source. So you have your boat, and you can go to a marina and use Wi-Fi WAN to connect into that. Andrew asked a good question. It's kind of back on the HD1 dome and the antenna. So I'll answer that real fast. What are the terms of performance between the HD1 and the coax cable main differences? Actually, that's one of the main points of the HD1 dome, which was really cool. The HD1 dome is a PoE Ethernet powered device. There's virtually zero attenuation because you have a motherboard, or you have your PC card, your PCI card modem, literally a little cable that goes into the antennas, and the antennas are in the dome. So you're not wasting cable length on loss. And then because once the modem receives that cable, that signal, and then the HD1 dome is the router, or the adapter at that point, then that goes via Cat6 cable down your length. So if you have a 30-foot length and I've got a 82G antenna with 8 cables going 30 feet down into an SDX plugged into a 5G module, or I have 2 HD1 domes with 30 feet, I have zero loss of signal over that 30 feet on the H2 HD1 domes versus the 6 or 7 dB of loss, or 5 or 6 dB of loss that's going to happen over 30 feet on the 82G. And so It does make a difference. And one of the cool things about the HD1 Dome is the ability to basically have lossless, because that RF signal is being received on the roof of your building or vehicle, and then it's being transferred to digital over Cat6. And so there's no loss at that point anymore, that the signal's already been received. SIM injector, there's no trade in signal strength. There's no impact on performance at all with the SIM injector. The SIM injector is just taking the SIM card certificate and sending it over IP. There's zero effect on performance or on signal strength or anything. It's simply just the SIM card is a certificate, and it's transferring this certificate from one location on your vehicle or boat or house or building or whatever to another location. So it doesn't affect performance, signal strength. It's not a router or anything like that. The mobility 20 and 22G. So the way our antennas work is you have the type of router, so mobility, maritime, etc. And then you're going to have the 20G or 22G. So the first number is the number of cellular antennas. The second number is the number of Wi-Fi antennas. And the last is whether there's GPS. So a 20 without the G would be 2 cellular, 0 Wi-Fi, no GPS. A 22G is 2 cellular, 2 Wi-Fi, GPS, and then the mobility. So it's going to be the mobility footprint, which is the same as the mobility 82G. Then we have the mobility 40 and 42G. So once again, this is going to be 4 cellular. This is great for your 5G. The 20G is great for your 2x2 MIMO, like your 4G. So like the BR1 Mini Hardware 3, it's a Cat7 modem, 2x2 MIMO, so you need 2 cellular. And then it does have Wi-Fi. So depending on if you want Wi-Fi outside or inside the vehicle, you choose either the 20G or the 22G. On the 40 and 40G, 42G, that's gonna be your BR1. So, and a lot of times, if you've seen some videos, we do the 42G and the 40G for like a BR2 Pro, right? Because you have your 2 Wi-Fi, you have 8 cellular, and then you have your GPS. So the having 142 and 140, or having an 82G for a BR2 Pro. Our maritime antennas are not only for maritime, and let me talk about those for a second. The maritime antennas come in 3 flavors. You have the maritime 10, which is just 1 cellular. Then you have the maritime 20G, which is 2 cellular and a GPS. And then you have the maritime 40G, which is 4 cellular and a GPS. I did a project in a rural area of Alabama. My cell phone was getting around 3 megabits per second of AT&T 5G. I needed to provide over 100 megabits of internet at this location, and I was not allowed to drill holes in the building, and I was not allowed to have antennas outside of my MDF. So I took an SDX Pro, 2 5G, one 5G module, two 5G modems, and then I installed the 2 of the maritime 40G antennas. So each 40G antenna, 4x4 MIMO, went to each of the 5G modems. I used T-Mobile and AT&T. I was getting almost 500 megabits download by over 100 megabits upload by switching from 0 dB of gain to the 3-foot long massive maritime 40G. I use the 40G anytime I'm inside of a building, or I need to make sure that I have good long range connectivity where the towers are unknown distance from me and I need to increase that capacity. And so the maritime 40G, even though it's called a maritime, it should just be the BA, if you know what BA stands for, 40G, because that's what it is. It is a very awesome, powerful router. And if you have questionable connectivity, you should try these out because they're epic. Due to the nature of the global capabilities of this, Benjamin, I'm not going to talk about price on the 40G, but if you email me, peter@westnetworks.com, with your geographic location, I'll get you in with the closest partner, and then that way they can give you pricing. The 42G has Wi-Fi, and that means it can broadcast Wi-Fi. So you can plug that into your BR2 or your BR1 Mini or your BR1 Pro 5G and actually broadcast Wi-Fi. Or you can do 2 42Gs for a MBX Mini, right? And that way you have the the dual Wi-Fi radios, for 2.4 and 5 Wi-Fi LAN and WAN. I like all the questions. Thank you, everybody. Oh, there is there. Oh, good. The 82G, 8 cellular, 2 Wi-Fi, and GPS. I did a project with this antenna. So I first received this antenna when I was doing I was traveling on I was doing a trade show in Philadelphia. Anyways, I was doing a trade show in Pennsylvania, and we were in the basement of this convention center, and I had my Speed Fusion Sprinter, my big 35-foot diesel, and we were kind of like, using that as our trade show booth because it was all wrapped Speed Fusion and Peplink. And we actually got the 82Gs the day we left for the trip. And so I drove up to Pennsylvania, pulled down the basement of this building, virtually zero connectivity. I installed 2 82Gs on the roof of my RV, ran the cables in a service box, went down, plugged them into an HD4 MBX 5G. The HD4 MBX 5G needs 8 cellular, or it needs 16 cellular, 4 Wi-Fi. So it'd be a 16 4G, right? So 282Gs gives me 16 4G. And so I had my 16 cellular, my 4 Wi-Fi, and my GPS, and I connected those to my HD4 MBX. We were getting over 800 megabits of internet with T-Mobile and AT&T. And then we were also broadcasting Wi-Fi LAN and provided the 82Gs on the roof of my RV. We could go the entire length of the convention center. It was empty. We were able to go the entire length of the convention center and be connected to the Wi-Fi. It was awesome. I've never seen something like that, and I've become a loyal fan of, a raving fan of the 82G ever since. We talk about selecting the right product. We've talked about the routers and our switches and our APs and our antennas, and now you go, man, there's so many things. How do we know what to do? How do we know what to select? And so when we talk about selecting the right product, there's factors to consider: requirement, budget, and expectation. And those really are the best criteria to evaluate when you're looking at products, because the customer has a requirement. I need to be able to stream content, 1080p content over 4 cameras, to my system. And in theory, you could say, oh, well, the UBR could handle that, right? It supports that amount of bandwidth. But in reality, the cell carriers, the signal strength, what you're going to get with congestion, they're not going to give you that throughput. And so what I'm always doing is I'm matching requirement to expectation, and then I'm picking the best router that fits within the customer's budget. And that's how I do it. So first thing I want to know is, what's your mission? I've been asked to talk. Sorry, we're going to go back real fast. There is one more antenna. Let me pull it up real fast on peplink.com because it's not in my slides. Boop. Give me 1 second. I have an anonymous person that asked me to talk about it. And actually, I forgot about it. So antennas, give me 1 second. Hey, there's my 82G on my Sprinter RV, right on the homepage of antennas. There's my Patriot with the first 80G antennas, and I installed it right on my RV. We also have now the slim antenna. The slim antenna they used to call it the I don't know, like the dash antenna or something like that. But the idea of the slim antenna is that you can mount this to a window if you don't want to drill holes in your vehicle. And so and you can do this on buildings too. So I mounted one to the window of my building, and just ran it and plugged it into the BR1 Pro. And so the idea with the slim antenna is for those that maybe you're renting a car, or you are renting an RV and you don't want to drill holes in the roof of your vehicle. You just want to take your BR1 or your BR2 Pro. You can buy 2 slim 42Gs or 40Gs and plug those right into your window, and then plug in your BR2, plug in the cigarette lighter adapter, and voila, you've got a mobile internet solution. And so the slim antennas are designed to be deployed anywhere without obstructing your network. And so you have the 22G, which once again, 2 cellular, 2 Wi-Fi and GPS, and then you have the 40G, which is going to be 4 cellular and GPS. Now, I think inside, unless you just for looks, you don't really need the Wi-Fi. You can just use the little black ones that come with it. So I would do the 40G on the BR1 or 240Gs on the BR2. But I did forget to mention that because my slides. Thank you, anonymous attendee. And so but I always focus on the requirement, the expectation, and then I try to find the budget. I don't look at the budget first, because if I'm looking at just the budget, maybe I'm outside of where I need to be, and or maybe my expectation will be wrong. Hey, I'm looking for a router that's under $1,000. Oh, okay. Well, what are you trying to do with it? Because what I don't want is a return, right? I don't want someone to say, hey, okay, well, $1,000, under $1,000, you get the UBR, the BR1 Pro. You know, you're looking for redundancy, get the UBR. Okay, here you go. Here's your UBR. Oh, well, I was trying to do a 4K, four 4K streams, and it failed. I want money back. So that's where the requirement and the expectation come into play. And so that's we would focus on that. Then we have our areas of connectivity. So we have mission critical connectivity, public safety, broadcast, telehealth, and maritime. And then we have our central connectivity. That's going to be our banks and enterprises. Those are people, usually when I think about essential connectivity, I'm thinking MPLS replacement or branch resiliency, right? They have a fiber line, they want to have bonded 5G failover, or they've got super expensive old school MPLS, and we're trying to move them over to bonded fiber. So they got maybe a 200 megabit MPLS. They can buy 2 1 gig fibers from 2 different carriers, bond them together, and have 2 gigabits of throughput instead of 200 megs of throughput, and usually at a less expensive. Or people are looking for better connectivity, retail, small offices, pop-up stores. They're just looking for increased reliability or better connectivity. And we have a retail store that right now is switched from paying tens of thousands of dollars and building for a really slow fiber or cable internet, and they just literally take the BR2, AT&T and T-Mobile, bond it together, boom, zero build time, it's up and running in minutes. Their construction crew just mounts the antenna on the roof and the router in the manager's closet or against the wall, and they're up and running, and they don't have to wait for carriers. There's no negotiations, there's no contracts. And that's what we're talking about, better connectivity. We're just making the internet better for people. And then wireless connectivity, which once again, I won't use the word wireless, but it's there. I would say cellular, but the idea, work from home, transport, IoT, ships, where you're doing, cellular, Starlink, Wi-Fi WAN, those types of things, and you don't have a physical infrastructure that you can tap into. I showed this off in the last module, but I'll show it off again here. Compare.peplink.com. So we can go to compare.peplink.com. And then in compare.peplink.com, you can choose all your routers. And right here, you can choose between the different types: balance routers, max routers, switches, and AP1s. So I can choose balance and then select different balance routers. I can choose max and choose different max routers. And so compare.peplink.com, if you're just looking for a quick tool to be able to compare the different products and get a list of products, this will be super helpful for your test. When you're taking tests, you don't need to memorize all the products and their specifications. You just have to memorize compare.peplink.com, because that is going to give you all the specifications that you need when you're looking at the different options that are available. Downloads and data sheets. So if you go to compare.peplink.com and you select a router, you can actually download the PDF right there. So from compare.peplink.com, you can select any router, BR1 Pro Cat 20, and there's your PDF, and you can click on the PDF, and then it's going to download, and then you can open that up. The next thing you can do is go to peplink.com, and you can go to support, downloads and manuals. And from here, you can select any router and grab the latest firmware, GA firmware, download the firmware, release notes for that firmware, and a user manual for the router. So it's a great way to access stuff. And if you're new to Peplink, if this is your first time and you're new to Peplink, there's no gating, no serial numbers, no warranty, nothing. I literally just did this. I'm not signed in. I'm peplink.com support downloads, and literally you can download the latest hardware, firmware, the user manual, and deploy this out to your routers with or without a warranty. I think that's the coolest thing that Peplink does. The way you're always security patched, you always have the latest. If the router's in support, like hardware support, you're going to get the latest firmware for it. Additionally, if you go to the support tab and scroll down, you can actually download our beta firmware right from here. So you just click there, which is going to take you to peplink.com open-beta-program, and you accept or agree to the terms, and then you can download the latest beta firmware. You'll get a download link and a PDF of the release notes. And if you've been following me on LinkedIn, I've been touting this and sharing that information. And so you can see the latest release notes right there for that. Someone just asked if they can find firmware downgrade, and that is a great question, and I will show you where that is. So if you go to firmware and manual and scroll to the very, very bottom, sorry, there we go. You should be able to say firmware archive. On firmware archive, you can download any GA firmware ever released right here. So I can search SDX, and here's all my SDX. Look at this, 8.1.1, 8.1. Look at 8.0.1. Let's see if there's any a 7. Nope. Okay. So 8.0.0 would be the first SDX firmware. So literally you can download any firmware that's been GA for a router. So I should be able to pull up like BR1, but you can get like a, there you go. Look at that, 6.0.3. I mean, come on, you can't get much older than that. So yeah, you just go to the firmware and downloads, and then you can scroll to the very bottom, and then you can access legacy firmware. And if you're using in control, you can actually roll back in control as well. And I'll show you how to do that. Speaking of devices and newer updates, we got the email about Peplink being Starlink certified. Are you going to spend any time talking about that for sales purposes? I wasn't, but I can. So we're still Starlink certified. Yay. I'll talk about Starlink when we go into the UIs and stuff. SIM injection to geographically different is probably out of scope for this course, but it does work. But I won't be talking about it in this course. There we go. Subaru. That was a fun one. I got a call. Hey, we're Subaru and you sponsor us. Can you help us? And I was like, sure. And so they have, you know, a racetrack. There's a whole bunch of area to cover. You know, they've got cameras that they're trying to access, or data they're trying to access, you know, all throughout the track. Then they have the paddock and their pit where they're doing service on the vehicles, and their engineers are downloading data and from the car. And so they have a whole bunch of different dispersed locations that they're trying to access connectivity. And we're trying to figure out the best way to do this. And one of the ideas was, oh, do we just build like a big mesh network? And the answer is you can't. It's just too spread out to do a mesh network. And it's not feasible to run fiber out there. And then there's no power at most of these locations. And so it became unstable. And so the end result was, let's just build a whole bunch of small networks. And that's exactly what we ended up doing. So basically all the routers, you have all the routers. All the routers have a different SSID, so we're not messing with default gateway changes. You have an engineering router, and you'll have a track router, and you'll have a pit router. And then basically they can go into that area, they can connect to the Wi-Fi on that area, and then they're able to connect, and all their internet is being bonded up to SpeedFusion Connect. And so they're taking 4 5G modems and they're bonding that. And you can see that that's one of our very first SpeedFusion cases. So they had the router just kind of sitting on a desk with the antennas like flopped over. And we're like, that's not going to work. And so Tim went back to the office, grabbed one of our cases. We re-racked their MBX 5G in one of our SpeedFusion cases, and gave them the antennas and the batteries so they can run all day without any power, as basically a massive hotspot. But it's really neat because they just have a whole bunch of different areas. So you have the paddock, the RV, and their media crew vehicles, and they just travel around, and they're connected all throughout the race course. And we kind of answered Q&A during the session, so we're going to move on unless there's any last minute questions, but otherwise we're going to move on to module 3. So in module 3, we're going to talk about Peplink technologies and security. And this is a weird one. There's only a few slides. So there's going to be a lot of me flipping and flapping forth between routers and UIs and giving you an overview of the UIs. Most of my routers are running 8.4.1 beta RC2. So that's what you're going to see me playing with. This is 8.4 training, so it's still relative. But if you see a feature that doesn't exist on your router, most likely it's because I'm running 8.4.1. There's a lot to cover here. This is one of the most intense modules that we have. We might not finish it today. And so just be aware of that. And so we're going to talk about Speed Fusion, what it is, deep dive in how it works, understand the benefits of Speed Fusion, and explore key features of Speed Fusion. And then we're going to go over in control. And I do have a YouTube video live right now that actually has a deep dive into in control. It's a 45-minute course just on in control 2.12. But I am going to go over in control, but I would encourage you to go watch that video. We're going to talk about advanced features. Well, then we're going to talk about the web admin. Then we're going to talk about advanced features, then security, and then firmware. There are two types of Speed Fusion routable. The YouTube video, I don't know if you know, but if you go to youtube.com/West Networks LLC, and I understand there are partners out there. This is no way or shape a promo for West. We are 100% Peplink in support. But if you go to youtube.com first says that, then go to our playlists, and we have Peplink University playlist right here. This Peplink University playlist. Here we have all of our monthly webinars, and then I also do my own little personal videos. And right here, you'll see an In Control 2.12 overview. It's 44 minutes long, and if you want to entertain yourself with more of my boring speech this evening or before the next webinar, highly recommend watching this before the next webinar. I really tried to go over every single section, and I'm going to try to hit most of that today. But I don't want to. I want to make sure we get through the important context of the training. So with Speed Fusion, you're going to have a layer 3 network. Layer 3 is going to be like routable networks, right? So my 192.168.1.1 on or 1.0/24 on site A, 192.168 2.0 on site B, and then those are routing over Speed Fusion. Then we have our layer 2, 192.168.1 and 192.168.1, and literally they're bridging. So my wife owns a health spa, and she has an X-ray machine and a PAC system. And often at night, she's reviewing all of her X-rays, and wants to be able to access those X-rays via the home. So I've created a Wi-Fi SSID at home called West Health Spa, and it's tagged a VLAN. That VLAN is a layer 2 VLAN back to the same Wi-Fi, the same network that the X-ray machine is on. So when she's on the West Health Spa network at my house, she's actually using the internet at the spa and accessing that X-ray equipment as if she was sitting in the spa. This way she can pull up her images and browse those images as if she was sitting right there connected to the X-ray equipment. We tried routing it, it didn't work, and so that was our workaround around it. And it was anyways, it created a really neat use case for layer 2 capabilities, and I thought it was really fun. And so Peplink does support multi-site layer 2 VPN. I also did a really cool project with another company on this, where we provided access to like a security zone that was unroutable. And so you can take unroutable networks and extend your infrastructure with those unroutable networks into using layer 2. And so you can extend your infrastructure basically anywhere in the world over Speed Fusion. Outbound policies, not really Speed Fusion, but it's where they put it. So we'll go with it. Outbound policies are how our networks, how we control the flow of traffic. And so we use outbound policies, OSPF, and BGP for routing. So it's basically we use outbound policies or routing protocols to control the flow of traffic or the destination. I believe layer 2 extension does support multicast. Actually, I know it does because we do Dante and stuff over it. Um, the so so with outbound, oops, sorry. Yes, you can use layer 2 and layer 3 at the same time. So we use subtunnels, and then you'll be able to have both those, and I'll demonstrate that. Benjamin asked me that question a little bit later, and I would love to answer that. So we use outbound policies, OSPF, BGP. So outbound policies and routing protocols. That's how we control the flow of traffic. And that can happen either on the WAN or inside SpeedFusion. SpeedFusion uses OSPF internally. So Peplink to Peplink SpeedFusion is going to be OSPF. And then we can then advertise that OSPF network over BGP into the LAN or into your core, or we can do BGP to the WAN and publishing public IP addresses. And you usually do that for IP resiliency on the first mile, that first hop out to the internet. And then we control the flow of traffic with our outbound policies. And we have 8 outbound policy algorithms: weighted balance, priority, overflow, enforced, lowest latency, least used, persistent, and fastest response time. Happily, Brock. Do it all the time. It's just redundant of the same information. So weighted balance allows you to distribute the traffic across different WAN links based on their weight. As a priority ratio, you can designate for each WAN connection. And so basically, if you look at this math here, if you do 10, 5, and 1, 10 of 16 packets will go over WAN 1, 5 of 16 packets will go over WAN 2, and 1 of 16 packets will go over WAN 3. It is not a priority. It's not saying use WAN 1 first, and then use WAN 2 and then use WAN 3. It's saying out of 16 packets or sessions, 10 of them will go over WAN 1, 5 of them will go over WAN 2, and 1 of them will go over WAN 3. And this is really important. Remember this when we talk about dynamic weighted bonding. So we support 802.1x network access control on the Wi-Fi and on the LAN, if that's what you're asking. Priority is use this connection until it fails. Then use the next one on the list until it fails. And the first one and the second one have to fail in order for the third one to take over. So priority is saying use WAN 1. And if WAN goes down, use WAN 2. If WAN 1 and 2 both go down, use WAN 3. And so priority is much different than weighted load balancing, because priority is saying only use it if it fails the health check. And that's important because it's not saying use this until it's horrible quality. It's saying use this until it fails. So a lot of times customers will have like a cable modem and it'll have high packet loss or high jitter, and they're experiencing bad, and they're like, why didn't my 5G kick in? Well, you have it in priority and the connection has to fail before it's going to kick in. And so your health check settings matter when we talk about failure detection, which we'll talk about later. Enforced says use this and use this only, period. Enforced has no backup plan. It is enforced. This is important for when you're doing VPN destination-based traffic or when you're running security application traffic. So for example, say you have a relationship with a security vendor and they're restricting a particular IP address. You can say, hey, destination to that vendor is enforced over this connection, period. It can't go over another one. The relationship's not going to allow it, even if it did. Or you could say, if I'm going to app.domain.com, enforced over SpeedFusion. That can only happen going back to my corporate network that's hosted in Dallas, Texas, or wherever. Somebody asked a question: if WAN 1 and WAN 2 fails and you're running WAN 3, will the traffic be restored? That is a checkbox that I'll show you, but it's terminate sessions on recovery. And so you can check that box and it'll move from WAN 3 back to WAN 1, or you can keep that off and any sessions on WAN 3 will stay on WAN 3 and all new sessions will happen on WAN 1. So you can choose whether or not you want it to move back to WAN 1 or if you want to stay. priority order on the outbound policy is different than priority on the main page, and I'll give you that later. When we do the UI, I'll go over that. Lowest latency. All new traffic is assigned to fastest connection based on the connection latency time. Lowest latency and fastest response time are similar but very different. Lowest latency, every 15 seconds, the router will go out to the internet and it's going to monitor 3 hops out, and it's going to assign a latency to each carrier. So it's going to say carrier 1, 3 hops out, carrier 2, 3 hops out, carrier 3, 3 hops out. Whichever one has the lowest latency, that's the lowest latency connection, and it's reevaluated every 15 seconds. It has less overhead than fastest response time, which isn't yet. So I wasted my time on that one. And so the idea is that the lower latency connections will be used first, and the higher latency connections will be not used until until they are higher or lower latency. So all new sessions are always going to happen on the lowest latency that's calculated every 15 seconds. Fastest response time, sorry, I'm skipping because I want to, this makes more sense to go here. Fastest response time, if I want to go to google.com, and I have 3 internet connections, the ACK is going to go out all 3 connections and say, hey, google.com. The first internet connection to receive a response back is the one that's used for that session. The other 2 will be discarded. And so what you're doing is you're saying every new session is going to be routed out the internet connection that is best for that destination, period. I pair this with my BGP. So in my data center or my office, we have 3 10 gigabit lines. I BGP advertise over those 3 lines, and then I use fastest response time. So basically, instead of downloading a route table and routing both based on lowest cost routing, I'm saying YouTube, what's the fastest, which internet connection can reach this YouTube video the fastest? That is the one that's going to stream across. So fastest response time is really neat when you want to make sure that every new session is going to happen as quickly as possible, because it's literally going to treat it just like a regular internet traffic. It's going to say, okay, I'm going to Google, ACK out to Google and all 3 internet connections. The first one will respond back. That's what's used for that session, and it moves on. And then the other 2 will get discarded. And so it's a really neat protocol. High CPU and infrastructure load overhead. Don't do it on Starlink. They're going to yell at you, or they'll yell at me for telling you to do it. So don't do it. Overflow says use this connection until it's at capacity, then use this one until it's at capacity, then use it at this one until it's at capacity. So say I have 3 200 megabit internet connections. I could program all 3 internet connections to 200 megabits, and then literally it will use them until they're at capacity, and then overflow to the next one. How often does it check for latency? Every 15 seconds. Recently added Starlink connection, max transgen, sense speed fusion. This year that was supposed to aggregate all 3. So we could talk, Jason, that's a really good question, but it's really, let's talk about that when we either offline and or when I'm talking about speed fusion. But I do, under that Peplink University, I do have a Starlink video where I actually address your specific concern. It's in here. Peplink University. Oh, here's your SIM injector. You guys, if you want to learn more about SIM injector, Speed Fusion Connect, edge computing, outbound if you want to deep dive outbound policy, there's a 1-hour video just on that. GPS ecosystem, security. Somewhere I have a Starlink video where I actually go over all of that. I apologize. And I talk about those different use cases, but we'll talk about that in module 4 would be the better location time. So overflow is going to overflow based on your programmed outbound or program WAN throughputs. Persistence will basically hold a session on a particular internet connection until that session is terminated, or until that internet connection fails. So persistence is really good for SSL, right? Hey, I'm accessing my bank on cellular 1. I want to make sure that it stays on cellular 1 the entire time. You'll hear me talk about session persistence over speed fusion. It's a way to use all the carriers and maintain persistence. But when you're load balancing or you have outbound policies and you're handling multiple carriers, session persistence ensures that my bank traffic is going to stay on that carrier until the connection is terminated or the carrier fails. Least used is kind of similar to overflow, except for it's gonna base the traffic on which connections use the least instead of overflow. So once again, I have those three 200 megabit circuits. If one's running 100 megs, one's running 50 megs, and runs 0, the next sessions are going to use WAN 3 until they're at 50 megabits. Then once they hit over 50 megabits, WAN 2 would be used until both of those are over 100 megs. Then it will then use WAN 1 at that point. So it's always going to use the connection used the least. Part of 8.4.0 firmware, they added the ability to do least used by upload or download. So now you can choose, do I want to do least used upload or least used download? We talked about fast response time. Furthermore, oh, that's funny. Yes, persistence would be similar to sticky sessions on other devices. Outbound policies work top down. So they're going to work from the top down. And so, but at the very top is always going to be SpeedFusion, VPNs, OSPF, VGP, and RIP. So if you want a policy to override routing protocols, you need to turn on expert mode and then drag your policy above the gray bar. You can do this on in control or in the router's UI. But if you have a default route 000 going somewhere and you're like, why is my outbound policy that's saying enforce peplink.com over WAN 1 and it's not working? Well, the reason is you have a 000 route that's the priority. It's the top rule, and rules are going to work top down. And there's a hidden gray bar, SpeedFusion, VPN, OSPF, BGP, and RIP, that's going to happen above your policy. So you have to enable expert mode by clicking the question mark, or in IC2, just dragging the rule above the gray bar. You're able to manage traffic to different SpeedFusion VPN networks with enforced or priority. And so you can actually route traffic over subtunnels where the destination is a particular traffic. This is advanced routing protocols for like if you want to prioritize stuff over a specific WAN link inside of a tunnel, you can do that with enforced or priority rules. And then we have SaaS destinations in IC2. IC2 meaning in control 2 cloud. So in the router, you have source and destination, and the destination you have like IP address and domain name. Well, in control, we have SaaS and region. And so you can say if the destination is Europe, go to my European Fusion Hub and then go out to the internet. Or if it's Dropbox or FaceTime or Google Meet or Google Workspace, go over a different internet connection or go over a SpeedFusion tunnel with WAN smoothing enabled or whatever you want to do. And we'll talk about that when we talk about that as well. But in control and outbound policies, there's some extra SaaS and layer 7 application capabilities built into in control. If you have 3 WANs on the same priority level and do not apply any outbound policy, what's the default mode? The default is going to be auto, and auto is basically going to be a weighted. It's just going to load round robin or load balance the connections based on their status. So default, if you have 3 WANs and you have plugged into a router, by default, it's just going to load balance the sessions equally across. By my recommendation, by the way, unless you have a specific use case. But if you have 3 cable modems, like my office here, I have a gig coax and a gig AT&T Fios, and I literally just load balance the internet. It's just auto with session persistence. So nothing special, and it's fine. Select the regions on in control 2. So we can do SaaS or regions. So here, once again, you can do destination region, and then you can choose regions and then have it go out specific internet connections or VPN tunnels. SpeedFusion requirements. SpeedFusion requires 2 SpeedFusion capable units. This could be a Fusion Hub and a BR1. This could be 2 BR1s. This could be a BR1 and an SDX. you need, or BR1 and SpeedFusion Connect, or Peplink's public cloud, which we'll talk about. But you have to have, in order to use SpeedFusion or bonding, you have to have two Peplink units, devices, software or hardware, for them to connect to each other. At least one public IP address or publicly addressable IP address on one of the units. And usually that's going to be your hub unit, and you're going to have that with a public IP address. Or once again, you can use SpeedFusion Connect, which I'll talk about. There are multiple configuration types. You have point-to-point, mesh, and star. Point-to-point is going to be a connection between two sites. It's just point-to-point. Meshed is going to connect all your sites to each other. And then star is going to connect as a hub and then spoke scenario. You can deploy in the UI, or you can deploy on in control. So if you're anti-cloud, all of our equipment works locally on the GUI. And so you can program it on the GUI, or you can program in with zero touch configuration on in control, our cloud management platform. Bandwidth, SpeedFusion has 4 flavors, and I'm gonna say 4.5 flavors. We have bandwidth bonding at the top. That's the ability to aggregate all of your connections together. We have WAN smoothing. That adds parity bits to create less jitter and lowest latency utilization. We have hot failover. That's going to be the ability to maintain session persistence between WAN failures. So you have a cable modem, 5G, you're bonding up to SpeedFusion Connect, cable modem fails, 5G kicks in, your voice transactions and point of sale transactions stay operational because SpeedFusion Connect is your hub. And then we have PEP VPN. That's our IPsec replacement. It's basically our zero touch provisioning of WAN to WAN connectivity. So there's no bonding or hot failover or WAN smoothing. It's simply just a VPN between two sites that uses OSPF instead of advertised tables. You can see hot fail over here. They have a little pretty image. You're going to go, oh, look, I'm on the internet. Oh, my internet fails. No big deal. It's going to just fail over seamlessly. So increased reliability, increased consistency, not really an improvement on bandwidth because you're just failing over. Hot failover, you can kind of see there, you got MPLS failing over to a cable modem, and yes, we can do that. And then you have your cellular on standby. WAN smoothing, well, actually, let me go back to this. So hot failover, establish a tunnel on all active links. Then it sends only the user traffic on one active link at a time. And then if the link fails, the traffic is quickly routed through the second tunnel, sub-second. Applications can operate uninterrupted during the handoff, hot failover. So Benjamin is being very persistent with this question, so I will ask it, or I'll answer it, but I'm not going to answer the IP issue. So is there a difference between AWS bonding versus the SFC throughput limitations? SFC is Peplink's public internet or public bonding service. It is limited to 200 megabits per second currently. And then every router comes with some of that for free. So basically think about it as a publicly available or dirty internet. You're going to have, Peplink has like a whole bunch of these. I think they have 16 or 19 in the country. And you can just tap into that. And I will show you this when we do the router UI demo. But then we talk about SpeedFusion, and we talk about how you have to have points. So I can SpeedFusion to an SDX in my data center with a gigabit internet connection. Now the SDX supports gigabit. Now I have 1 gigabit of throughput. I have a gigabit fiber, and I have an MBX out in the world. Well, the MBX only is 500 megs, but I could use all 500 megs of the MBX because I have a gigabit internet connection plugged into an SDX, which supports gigabit unencrypted. So that means if my MBX can get 500 megs, the SDX, because it's connected to a gigabit internet, is also going to be able to provide the 500 megs needed to the MBX for the bonding. And so SpeedFusion Connect, Peplink's kind of hosted, Peplink's private or public hosted bonding service, you get 200 megabits per second, and then you have a number of terabytes that comes free with different routers. Some routers come with 2, some with 1, but the idea is you have some bandwidth or some gigabyte package that's there, and then you can up the gigabytes as you use them. If you host your own SpeedFusion with a Fusion Hub or a physical router, and AWS, Azure, on your own premise, your data center, at a colo, Now you get unlimited throughput. Well, you get unrestricted throughput that would only be limited by the device you put in place. So if it's a Fusion hub that you can deploy in AWS or in the cloud or in your own private cloud, Fusion hubs are unlimited throughput. So it's going to be limited by the processor and RAM that you have assigned to your virtual instance, not by the software itself. And that's the benefit of the Fusion Hub, especially in a private cloud or AWS. You give it as much bandwidth as you want, and then AWS is just going to charge you for the bonding. Would love to see a video on the best way to set up Peplink for VoIP. We're going to talk about, somebody asked about Peplink for VoIP. We're going to talk, when we talk about configuring SpeedFusion, I'm going to talk about WAN smoothing, and we're going to get there in just a sec. Well, actually, we're there right now, and we'll talk about VoIP and video applications. So hot failover, we have a cable modem, we have a 5G. We don't want to waste 5G bandwidth. So we play with the cable modem fails, 5G kicks in, voice and video and point of sale sessions all stay active, and then all your internet just kind of moves over. WAN smoothing is the idea of combining using parity bits so to reduce or eliminate packet loss and jitter. And so the idea is if I have two internet connections and I enable WAN smoothing, my voice traffic is going to go over both of these at the same time. It's not going to load balance. It's not going to split the traffic. It's going to be a 1-to-1 ratio over the both internet connections. If this internet connection fails, because this one is sending the same information, my voice and video doesn't fail at all because it's using this one and this one. If this one fails, same thing. If this one has packet loss, this one's solid. This one, the packet's going to be delivered. So WAN smoothing uses extra parity bits to replicate the transmission of set packets over multiple internet connections. You don't want to turn on WAN smoothing unless you have more than one internet connection. There are some use cases where you might want to have it on one, but for the most part, any normal people watching this video, WAN smoothing should be used for 2 or more internet connections. Think about like a RAID array for your WAN connections. You're adding resiliency by duplicating packets. So you are going to pay a cost of bandwidth. So if you have a 100 meg circuit and let me think about the best way to do this. If I have a 10 meg circuit and a 10 meg circuit and I'm doing WAN smoothing, I'm not getting 20 megs, I'm getting 10 megs because I can only send the data. The data is going to be split and transferred across, and so we're going to have WAN smoothing. And it's great for VoIP, video conferencing, and broadcast. WAN smoothing creates your tunnels between the WANs, and then it's going to duplicate traffic. So you have your original, and then on your original traffic will be transmitted, and then you'll have duplicate on normal, medium, and high. So normal is going to be a 100% duplication. Medium is going to be 200% duplication, and high will be 400% duplication. Establishes a connection on all active links, sends redundant copies of the traffic to each active internet connection. The copy that arrives first is used. This is very similar to fastest response, but it's for your entire session throughout. So it sends it on all connections, and then the first one received at the other end is used. They have a really cool little image here, kind of demonstrating WAN smoothing. WAN smoothing has a feature called forward error correction. If you don't want to waste an entire your entire overhead for packet loss mitigation, you can use forward error correction. This is great for one-way communications like TV and video streaming. So if I'm transmitting an image, a 1080p image from my mobile vehicle up to a broadcast or to your producer, I don't need to consume I want to mitigate packet loss. I want to make sure that if there is packet loss or congestion, that the video is received well. And so we have forward error correction that only uses 13 and 26% overhead instead of 100, 200, and 400% overhead. WAN smoothing for select traffic, for example, only for VoIP. Yes, so I'll talk about that a little bit later. But the idea with outbound policies and subtunnels, we'll be able to apply a WAN smoothing tunnel, a FEC tunnel, a bonding tunnel, and then we can use outbound policies to control it. So I can say VoIP goes over WAN smoothing, my live stream goes over FEC, and my internet traffic goes over bonding. So you can actually you can combine the technologies we're demonstrating. So I showed outbound policies, we talk about WAN smoothing, and we're going to combine those two together and create awesomeness. Outside the bandwidth tax on WAN smoothing, is there a substantial processing tax? I haven't noticed a substantial processing tax. It's mostly a bandwidth tax. If it is, it's a nominal processing tax. And maybe on like a low end router it does, but I haven't really noticed it that much. So forward error correction basically just fills in, sends reserve packets and then fills in where there is potential loss. And the idea is to mitigate packet loss. It's very common over cellular and like Starlink and things like that. So the idea is we just have this forward error correction that uses less overhead, but still provides a little protection from packet loss, especially when you're doing like UDP transmissions. If you're using an HD4, do you need a WAN connection as well as cellular bonding to use WAN smooth? No. Well, a WAN connection is cellular. So cellular is an internet, that's a WAN. So to do WAN smoothing, you need more than one internet connection, whether it's an Ethernet WAN, a Wi-Fi WAN, a cellular WAN, or a like a Starlink. Good question. And then we have bandwidth bonding. Bandwidth bonding combines the speed of bandwidth into multiple WAN connections. It originally started out for me as an MPLS alternative. I used to attack MPLS circuits. Hey, like, once again, I mentioned earlier, you have this 200 meg MPLS between your branch sites. It became not efficient quickly as bandwidth demands increased. And so you could basically buy 2 1 gig lines and combine them together for usually less expensive than an MPLS. So the ROI was really good, increased throughput, and reduced cost. And so it was kind of like a win-win. And bandwidth bonding provides that. So the idea is you have, once again, 2 100 megabit connections. We combine the bandwidth, and you have 200 megabits minus overhead. Bandwidth bonding establishes a connection on all active links. It splits the application traffic across those active links. Increased throughput is possible, and there are combinations that are not realistic. And when we talk about not realistic combination, it's, if you have a 1 gig line and a 10 megabit line, well, 1 gig plus 10 megs minus overhead is less than 1 gig, but also there is the ability, the traffic. So you can't effectively bond links that are more than 50% disparate of each other. So you want to make sure that you are bonding like connections, bond for cellular connections. You don't want to bond a cellular connection and a fiber connection. You can forward error correction, or you can hot failover a fiber and a 5G, and you can hot failover a fiber and bonded 5G. So you can say, here's my 1 gig fiber, here's my 4 5Gs, hot failover. So I bond those and hot failover the connection. That way, you've got your 1 gig fiber line, and then you have that 5G bonded. But you want to bond like connections for the most efficiency. People bond disparate connections all the time, and it will work. It's just not going to be optimal. And people sometimes are disappointed by the total capacity because they think that they should be getting more than they're going to get when you're bonding non-like connections. If a link fails, the traffic is routed quickly through the sub. Oh, okay. Well, that was a mistake there. I'm not going to read that one. And applications can operate uninterrupted during hands-off hot failover, which happens on bandwidth bonding because they'll just move over. Somebody asked why consistency is low on bandwidth bonding. And the reason why consistency is lower on bandwidth bonding is because there's no packet resiliency happening. So you can have packet loss on bandwidth bonding, and also bandwidth bonding, which we'll talk about in a few minutes, but bonding is sensitive to latency. So if I have once again, fiber and 5G, right? So I have a 10 millisecond fiber line and a 150 millisecond 5G line, and I bond them. I don't WAN smooth, but I bond. My latency is now 150 milliseconds. So the latency of your bonded connection will be the lowest latency. This is, by the way, a test question, is the lowest latency of all of your connections. So once again, causing, people, like, hey, I've got this 10 millisecond fiber line. Why am I now getting 100 millisecond latency? Well, it's because you're connecting it with an internet connection that's 100 milliseconds and you're bonding. WAN smoothing and hot failover don't have that. Hot failover is going to use that fiber, that 10 millisecond, and then fail over to 5G when your connection drops. WAN smoothing will send duplicate packets. So basically the 5G is never used because the fiber is going, even though the transmission is going over the 5G. But the neat thing about the 5G, like WAN smoothing with 5G and fiber, would be there's like zero interruption. Even that hot failover is going to have like a sub-second transfer. With WAN smoothing, it just keeps going over the 5G. Your latency will go up, but you're not going to be you if your fiber's working, you won't notice that latency. You'll get the 10 milliseconds. So bandwidth bonding the idea is to increase speed. And once again, you want to combine like connections. That is a split tunnel, which we're going to talk about. Do not bond with Hughes. That 100%. Hughes is a bursted service, so they queue your packets, and anybody that's bursting through capacity means that all those packets are being held and then they're being transmitted. They're being held and they're being transmitted. So you can't bond it because it's holding those packets. It won't work. Okay, so this slide is actually a mix of two slides. I apologize. This is split tunneling or subtunnels. Inside SpeedFusion, we can create 5. This is a test question. We can take 5 subtunnels inside a SpeedFusion VPN. So inside one of those 5 tunnels, you can configure different options, like use fiber, and then use fiber with 5G and a hot failover. Then you can say bond my WAN smooth, my fiber and my 5G. Then you could say forward error correct my fiber and my 5G. And then you could say dynamic weighted bonding, bond my fiber and 5G, or just use my 5G with failover. And so you can create tunnels to say, use these different internet connections with these different priorities and different configurations. You could even say, bond my cable, my 5G, my fiber, and limit it to 20 megabits per second. And that's my guest internet. So you can create subtunnels that allow you to know the total aggregate to SpeedFusion Connect Protect would be 200 megabits per second. So if you're going to SpeedFusion Connect, it's 200 megabits per second. So these subtunnels that you configure different protocols, they think you can use outbound policies to use those protocols. So I can say my WAN smoothing, my forward error correction, and my dynamic weighted bonding, or my bonding. And then I can say my internet traffic goes out bonding, my Teams and Zoom and WebEx and those things go out WAN smoothing, and then my 1080p camera feed up to the production studio goes out my forward error correction, all in the same tunnel to my corporate office. So I'm able to say, use my internet in different ways based on the need or the application mission I'm trying to accomplish. A lot of times you'll see when I'm doing my sales presentation, I'll say, well, we're trying to accomplish the mission. And so we'll talk about that. James asked if we can use dynamic weighted bonding and WAN smoothing at the same time on the same tunnel. And yes, you can enable dynamic weighted bonding and WAN smoothing at the same time. Dynamic weighted bonding is a little bit different though. We'll talk about that later. So now we're going to talk about in control. So we talked about SpeedFusion. Now we're going to talk about in control, kind of switching gears here a little bit. So I got I'm going to try to remember these things. So I'm going to pull this out, move it over here, pull this in. This is going to kind of keep me focused on what I'm trying to do. Okay, so I'm in my Peplink University. So the idea here is to talk about zero touch configuration. And I'll pull this up real fast. So zero touch configuration, there's a lot more to in control than just zero touch configuration. We're actually going to do a PCE training of the next level up that's going to be based on this going into like high-end configurations. The idea is to introduce you without overwhelming you. So if you're new to Peplink, the goal here, you're probably already overwhelmed, and I apologize, but the goal here is to introduce you to the technologies, so you can refer this back in the future and prepare you for your PCE, which we're going to delve into these and actually configure these as part of the test. But zero touch configuration is a big proponent of some of the stuff that we're trying to do. And with zero touch configuration, we can basically manage a lot of routers very quickly. And we do this with InControl, our cloud management platform. And so we have a bulk configurator that allows you to have a master configuration file that's just pushed to all your routers. So you can put in thousands of routers in a matter of seconds. Remote device IP address configuration. So you can manage the IP addresses of those routers. Bulk outbound policy configuration. So we talk about outbound policies. You have 1,000 routers out there and you want to have them follow a particular policy. You don't have to log into each of these routers. You can figure that once and all of them will get it. Bulk firewall policy configuration, route advertisement, OSPF and RIP and BGP, centralized firmware management, centralized Wi-Fi configuration, a better and centralized captive portal capabilities, connection testing, and then VLANs. So let's look at InControl a little bit here, and I'll give you a dive into it without wasting, not saying wasting, that was a bad one, without consuming maybe too much time. Yeah, so the PCE will just continue on the PCA. So you have to, in order to do the new PCE, you'll have to pass the PCA in order to take the PCE. And I'm working on that content right now. Okay, so InControl is broken up into 3 tiers. You have the organization, which is what we're at here. It's going to be a dark orange. Then you have a group, which is going to go into a lighter orange or yellow, whatever, how cream or whatever you want to look at that, whether that color is. And then you have the device, which is going to be white. You'll see the white text here when I click on this device. And there are different settings that apply at the different levels. So if you see the white here, that means you're in a device. If you see the cream color, it means you're in a group. And if you see the orange, you're in an organization. And if you notice, the menu changed based on that. No, you cannot get a static IP address in SFC. You need to use either Fusion Hub in Azure or AWS or like a SDX with public IP address. So at the org level, we're going to have organization level reports, which is going to be our SIM card reports, our SpeedFusion configuration. So if you need to create a SpeedFusion tunnel between groups, like maybe you have your data center and then you have branches and all of them are their own group and you want to span groups, you can create configurations at the organization level that will then allow you to connect devices across your groups. And then on organization settings, you can add devices. And then you can add devices to a group. So you can click add device, put in the serial number, and it'll ask you to choose which group you want to add it to. You have device management. It's going to give you a list of all of your devices across all of your groups. You can create a group. You can go into group management, which, by the way, from group management, you can delete groups, but you can also create new organizations. So say I created a group, I have this home network, and this customer or whatever wanted to have their own organization, and you don't want to delete all the configuration options in that group. You can click move to new organization, give it the organization network, Peter's home network, click proceed, and then it will literally take that entire group and all of its settings and create a new organization, cloning the group and user administrators as the organization administrators, and then you can just change the users. But it literally clones it. It'd say Peplink University. Everything would be the same, except for it would just be by itself in its own organization. Report emailing lets you send out reports, so usage reports on a monthly, weekly, or daily basis. And then when you do turn this on, you can select the recipients for it. Firmware policy at the organization level. I personally don't recommend this. I like to control firmware on groups and or individual devices. But here, if you do want to set a particular firmware, I can say all my BR1 minis are going to run 8.4 firmware, and boom, if if they're following organization policy, they're all going to be upgraded across all your groups. And then the operational log, for privacy, I'm not going to click this. Operational log literally shows you every transaction and user that does to end control. It's incredible. So this should be fine. I can show you this. So the operational log literally will say, like, for example, Peter West, super admin, like logged in, right? So I signed in. Peter West signed in. Peter West signed in. Here, Peter West, SpeedFusion Rebel. So I group SpeedFusion Rebel, SpeedFusion device manager, device name, and I changed the name of this device. You see, I updated the firmware of this device, updated the firmware of this device, updated the firmware of the, you can see 8.41 build, and I've been upgrading between the different beta builds on my backpack. And so you can literally see every single thing that happens in your organization at this level. It's a great, great audit trail. Organization settings lets you configure organization admins that span across all of your groups. You can set your idle timeout. You can do two-factor authentication, authentication with a password. So you can set all of your user, you can upload your logo, your default address, AWS access key, FlightAware API, and you can even remove the device or it tells you how to remove the org. So at the organizational level, you're really managing how In Control is managing or how you're interacting with In Control and your devices and groups and In Control. Once you go into the group level, your menu is going to change. Yes, it'll tell you the organization log shows you which user made which change. Like you saw Peter West change the name of the SpeedFusion Renegade. So it'll actually show you. It's great. We've caught a lot of problems like training and things like that with the organizational log. No, you can't modify the reports. So in my group settings, I then have my dashboard. And so this is cream. So it's going to change that cream color. I'm going to get how many's online, offline, if my warranties are expiring, number of clients, my internet availability, and my device availability. This is a backpack, so it's off a lot and on a lot. You can see my two devices. So I got SpeedFusion. I'm going to be using this specifically for a lot of demos today and throughout the training here. So we're going to have our backpack, and it's going to be bonding back to the head end. You can see my prime care is expiring, so I'll have to renew that here probably today after this webinar. How long it's been online, what WANs I'm using. So there you can see my AT&T and my T-Mobile. You can see I'm also on Wi-Fi WAN, just in case. You can see my cellular firmware, my bandwidth and my clients and my firmware. Up top, I have my reports. Now my reports changes a lot. In the organizational level, I only have SIM card reports, but in the group, I have device reports, Wi-Fi reports, usage reports, SIM card reports, captive portal reports, connectivity test reports, event log, and tag. So if I go to device reports, it's going to show me the top devices, clients used, top client usage. So you can see there's my Pixel Fold, and I've used 2.8 gigabits of throughput. My tablet is using 2 gigabytes of throughput. Clients by manufacturer, you can see Intel and unknown. And then you can see utilize my user. Once this is my backpack, so it's going to have my laptop and my phone basically. And you can see utilize this users. You can see it's last 7 days. I can change this to last 31 days. Get a little better view, right? You can see a better chart. And once again, you can see there's my blade and my fold, and you can see the utilization. So my blade used 8.4 gigabytes over the last 31 days. And so you can kind of see that traffic there. Usage reports gives you a little bit different view of the same type of data, but I find this to be a little bit more, I like this, is all I could say. So you have data use hourly, daily, and monthly. So I can pull up hourly, I can pull up daily, or I can pull up monthly, and I can do gigabytes or terabytes. And then I can do selection of all devices by products or tags. So if I say, I want to show just my mobile routers, my BR2s, and this is going to show me just the BR2s. If I only want to see my BR2 on T-Mobile, I can say, here's my T-Mobile data consumption. Here's my AT&T data consumption on a monthly basis or on a daily basis. And so I can run reports based on different needs that I might be having or different stuff I want to calculate. Um, Event log shows you all the events that are happening to this device. So you can see my in this group. So here's my accepted, TLS for Speed Fusion. So my Speed Fusion connected here when I booted it up just before the webinar, and you can kind of see all the different, reports that are happening on this device. It's not user. This is device level. Operational log is going to give you users. This is going to be devices. And I can filter this report. I can bring a lot more data. So you have WAN, LAN, wireless LAN, IPsec, PPP, and you can see a lot more stuff happens now when I turned on everything. So you can see I've caught MAC conflict. This is great when people are having performance issues. I'll say, hey, show me MAC conflicts, and you can see if there's loops on the network. Real-time throughput is going to be right here under usage. You'll see the real-time throughput right there. And then, so yeah, event log, and then tags, it just shows you the tags that are currently in use, which I don't have any on this particular group. Somebody asked what Earth, Mars, and Venus means on IC2 subdomain. You're going to see 3 planets that are available, or that you might have. Venus is basically Peplink's beta testing or insider preview, right? You're going to get the firmware first. It is not designed for production use at all. I've had complete crashes of data on it before if they push something out. So Venus is your beta. Then firmware is going to go to Mars and then Earth. So if you're looking for the most stable planet, it's Earth. And if you click the little notification bell up here in the top right-hand corner, you'll actually see right here, in control 2.131. Here's the changes. And look, Venus is 11.6, Mars 11.20, Earth 11.27. So it went to Venus first, then Mars, then Earth. Most normal people can only get on Mars and Earth. Venus, you do have to be a partner, and then you have to request it personally. But Mars and Earth will be your 2 planets that are publicly available, and you can see that Mars gets firmware before Earth. So if you want the most stability, I highly recommend staying on Earth. And then you can click on this and see all the changes that happen, and it's kind of fun to go through that. And so, and then, so after we have that, then you can go into our SpeedFusion VPN, and we can do configurations of our VPN. So I can go to, I can show Captive Portal reports. I don't have a Captive Portal, so it's not going to show anything. That's why I skipped it. But Captive Portal ports will show you summary, portal access, overview, client types. I just don't have one set up. We can set one up during our during this, and actually I'll connect like a phone or something to it and generate some reports for you. And then Captive Portal dashboard is going to be kind of boring because once again, I don't have anything there yet, but we'll set it up. SpeedFusion configuration. Here you can see I've got my SpeedFusion between my BR2, which has GPS, so this will move around going to my head-end unit, and so you can see that right there. And there's my profile, and we'll go over this more. Right now, I'm just showing you in control, so we can go over that more. But SpeedFusion is part of our zero touch, so you can click Add Profile, click Star, choose a head-end unit, click Next, choose a remote unit, click Next. You won't be able to create this because I already have a profile. Click SpeedFusion. You can select as many devices you want on that. And here you can enable and disable encryption. Encryption adds an extra 4% of overhead. So if you want the fastest possible connection and you don't need SSL or encryption, then you can turn it off. You can NAT mode, which will NAT the VPN to my untagged LAN of my hub. You can change the data port from UDP to TCP or custom ports if you're trying to get around firewalls. You can bond and send all traffic. This overrides outbound policies and just sends all traffic. I don't recommend this. I like outbound policies. You can set your link failure detection time. You can enable WAN smoothing. You can enable WAN forward error correction. I do not recommend doing both of these at the same time. You should only do one or the other. You can set your path costs, and then if you check this show advanced options, Someone had asked, can you enable dynamic weighted bonding and WAN smoothing? And the answer right here is yes. So I can enable dynamic weighted bonding, which is Peplink's new bonding technology, which we'll talk about. And then you can enable WAN smoothing right there. And then you just hit finish and it'll create those tunnels and you'll see the tunnel right there. So SpeedFusion configuration. Wi-Fi, we can set up our SSIDs. So you have the Peplink SpeedFusion backpack and you can, so there's my Wi-Fi. I can click on this and you can see I've got my SSID name, which devices I want this to come through, whether I want it to be on all devices, some devices, and I can choose a tag, or all devices except, and I can choose a tag or tags. I can set my security protocol. So you can see there's a whole bunch of, we have open, enhanced open, WPA3 enterprise, personal, WPA2, WPA3 personal, WPA2 personal, WPA2 enterprise, WPA2 personal, and WPA2 enterprise. Ooh, say that 5 times fast. Set your password. I can do layer 2 isolation, which will isolate the wireless clients on a layer 2 level so they can't talk to each other. If I have multiple APs, I can enable fast transition so that you roam between the devices smoothly. We have our SID availability, so I can hide or show the SSID. I can block LAN access and I can block VPN access. So if I have a guest network, I can block LAN, I can block VPN, and I can enable layer 2. I have just block. And basically it can only get out to the internet. I can also do a custom VLAN. And I can select a guest VLAN, which once again, we'll create that when we go to do it. Restriction mode, I can restrict by MAC address. I could do either deny all, allow all, or I could do radius MAC authentication. And then we have our multicast filtering, radio selection, either 2.4 or 5, and whether or not I want to disable, prefer, or force band steering to the 5 gigahertz, by the way. I can set the maximum number of clients on 2.4 and 5 gigahertz. And then I can build a schedule and a firewall. Cancel. Let's see how a second. Done. Done. Can you show capture reports? Yep. Andrea, I'll do we'll set up a capture report and I'll try to better demonstrate that. Somebody anonymously asked about IP pass-through. We'll talk about that later, or send me an email. Yes, fast transition is 802.11r. Somebody asked a question about a Wi-Fi controller. If you can restate that question for me. Okay. Then we have our network settings, and this is going to be our outbound policy, firewall rules, grouped networks, access control list, VLAN networks, LAN network settings, route advertisement, captive portals, and connection tests. And then since we're getting a lot of questions about captive portal and stuff, we're actually create a guest network with a captive portal here. So we have outbound policies. So outbound policy, I can click on this, and you can see I've already got a policy. It's my backpack. And so if I click on this, I've got WAN smoothing. And my WAN smoothing policy says source any, destination, Google Meet, FaceTime, Lifesize, Microsoft Teams, WebEx, and Zoom, go over my connection to my head end with WAN smoothing. And then if that's down, fail to the next rule, and then terminate sessions on link recovery. Someone asked about if the connection goes down, can you have it move back to the WAN 1? That's this checkbox right here. So basically, if I start a Zoom meeting and the router is booting up, once the tunnel is up, it'll actually hiccup and reconnect over the WAN smoothing. Then I have bonding, and here I just say any SpeedFusion dynamic weighted bonding. And so I'm go to my head end with the subtunnel dynamic weighted bonding. And so what I'm doing is I'm saying, if you do the top down, so you see there's my SpeedFusion OSPF and RIP rules. Then I'm saying if it's one of these applications, use WAN smoothing. Anything else, go over, just use dynamic weighted bonding. And then if the tunnel is down, if it's not even up, or my head end goes offline, then go ahead and just load balance my internet connections the best I can. Yes, you can turn off. There's actually, so a funny way is, so I was asked a question about Wi-Fi, which I'll go back to it. They said if if I don't want my clients to use Wi-Fi, can I turn it off? So there's a couple ways you could do this. One, you could do it on a security layer, and then two, you can turn it off. So if I go to the SpeedFusion backpack, let's say I don't want my laptop to connect to it, I can actually just turn the Wi-Fi off right here. So I can click on SpeedFusion backpack and turn it off, which I would be able to show you in a minute. Alternatively, I could go and I could tag these devices. So I could tag and I could say mobile. So I could click tag, add, click mobile, click add, and it's going to add this tag right here called mobile. There it is. Then under Wi-Fi, group SSID settings, I could say the device section on devices except mobile. And so literally this Wi-Fi SSID would push to any device except mobile. What this would do is basically not broadcast an SSID at all. So if the SSID, if I for whatever reason didn't want to do it, I didn't want to have Wi-Fi even, or just delete this SSID here and turn on Wi-Fi management. So when the routers turn on, they'll connect to in control. There's no SSIDs listed, and it just won't broadcast any Wi-Fi at all. But if you actually want to turn off the radio, you can just click on the device and then turn off the radio right here. Just toggle that switch. But you have to do each device one at a time. And then under Wi-Fi radio settings, you can configure the actual capabilities of the radio. So your channel width, your power output, boost, max clients, and signal strength. Signal strength is really important if you want to do fast transition, because you don't want to hold on as you go. So you could say like -70 dB, -70 dB, and then as you roam from this room to the other AP will pick up, and you'll fast transition between those APs better. But you want to make sure you set a minimum signal strength. So if you find a fast transition isn't working well, check your signal strength settings. Yes, so Wi-Fi does work on a schedule. So if I create a Wi-Fi SSID, I kind of showed that a little bit, but it's weird because some of the settings are, so schedule, always on. Under settings, device schedule, I can create a schedule. So I can go to device schedule, hit save, add. I can say work time, work hours, and then clear out the times, Sundays and Mondays. Oh, here you go. Oh, look at that, 8 to 5. There we go. 8 to 5 weekdays. So work hours. Hit save. And then I can go to my Wi-Fi group-wide SSID settings. Click on this, go down to my schedule and say work hours. So you can customize work schedule, and then this SSID will only broadcast Monday through Friday, 8 to 5. Wi-Fi on a schedule, yes. Is it possible to get through a splash page comfortably using Wi-Fi WAN? So someone's asking if you can get through a splash page using Wi-Fi WAN. Yes, it is. When I get to the GUI, I'll talk about that. So when I get into the GUI, the web UI, I'll show you how to do that. Remind me, anonymous person. So now we have this SSID. Once again, I kept it all available, but you can then have that schedule. So in outbound policies, I talked about that already. So I can create a new rule, and here I can do source, IP address, IP network, MAC address, access control list, grouped network, client type, and a client associated SSID. So I can actually choose an SSID. Say if you're connected to this SSID, follow this policy. Or I can say if it's a client type and it's an iPod, follow this policy. Or I can say if it's part of an access control list, which I'll show you how to create, or a grouped network, which I'll show you how to create, or it's in an IP address network, then follow these policies. And then we have those 8 policies: the weighted, the persistent, the enforced, the priority, the overflow, the least used, the lowest, and the fastest response time. And so you can then choose the algorithm and then set up your policies. Traffic shaping is a big deal when it comes to SD-WAN, because that's controlling the flow. So traffic shaping or SLAs, you know, that's going to happen right here. And you do get these SaaS capabilities, the region and the SaaS applications that you would not get on the device itself. So I'll show you that too. Firewall rules. So I can come in here to firewall rules. I can turn on the firewall, hit create rule set. And so here I could say default firewall rules. And from here, I got my outbound policies, my inbound policies, my internal policies, and my intrusion detection DOS, and my local service. So for example, I could say default inbound, deny. We should not allow anything in our network. Then outbound, I could say default deny, or I could default allow. Let's do default deny. Then I could add a rule that says countries, or I'll say regions. And I could basically say if the destination is a region and I'm in the United States, so this is not about anybody else regionally. I would say, you know, US, UK, I think United Kingdom. There we go. I think someone said they're from Colombia, so I could say allow Colombia. Someone said they were from there. And then, you know, enable event logging and allow and hit OK. Then I could add a rule that says allow SaaS applications. So I could say if the application destination is a SaaS, so it's Dropbox or it's Exchange or it's Google Meet or FaceTime or InControl, and you can pick all these different applications, Zoom or WebEx, Peplink Remote Assistance. I mean, like literally like SharePoint, SpeedFusion Connect. So you can choose all these different SaaS applications, Office 365, Microsoft Services, Microsoft Teams, Google Workspace, allow that traffic. So rules work top down. So what's saying is, and I can drag this rule above region. So basically I'm saying, is it an application that's allowed? If yes, allow the traffic. Am I going to one of my, if not an application, it's not one of those applications, is the destination in the United States, United Kingdom, or Colombia? Yes, perfect, allow that traffic. Everything else deny. So then I could create a rule and say, well, I want to make sure my DNS works. So I can say DNS, and I can say, if the destination is an IP address, 8.8.8.8, and the protocol is DNS, allow that traffic too. Hit OK. So now I'm saying, is it one of these apps? Allow it. If it's in one of these countries, allow it. If it's this DNS server, allow it. Block everything else. And so you can create these rules that now have these outbound rules and these inbound rules. And then internal rules is between VLANs. So I could say, is it from one of my approved laptops on a MAC address to my approved server list? And so you can create internal rules that are between your VLANs or over your SpeedFusion tunnels. Then I can go to content blocking, and I could say, well, I want to make sure I block BitTorrent. So let's block BitTorrent. And I'm not a huge Apple fan, so I'm going to say, let's block Apple Cloud. I don't want that. I don't want that traffic on my router. So I can say Apple Cloud. Give me my Apple. I want. Okay, well, I'll say iTunes. Apple, iTunes. Boom. And so now I'm blocking BitTorrent and iTunes. I can also block adware, proxy anonymizers, aggressive, malware. And then I can say update my database automatically on my router. And then I can hit save. And literally creating a rule on my router that is blocking countries. It's allowing Peplink services and these different features and capabilities, and has my content built right into it. And so now we have a firewall policy. Grouped networks are groups of IP addresses. So I could say servers. 192.168.100.0/24. 172.16.52.0/24. I got 2 data centers. There's my server IP ranges. And then I could do add a group network. I could say corporate VLANs, corporate networks. 192.168. Let's do 10. Say 10.100.0.0/16. All my corporate traffic is on my corporate VLANs right here. So my corporate networks and my servers. Then I can go back to firewall rules. Oh, I hit no. There it is right there. Yay. Click on my rule, go to my internal networks, add a rule and say, if the source is a corporate network and the destination is my servers, allow the traffic. I could say servers and hit OK. And then I could say add a rule, servers deny. Source any, destination, grouped network, servers, deny. Hit OK. Now I'm allowing my corporate network to my servers, but anything else, guest networks or anybody else, is denied. So whether they're on a VPN, they're corporate, maybe they're just browsing around trying to snoop, it's going to block it. Now you could say, well, what if I want to block specific MAC addresses? So I hit save, go to access control lists. I hit add access control list. I could say corporate PCs. 00:00:00:00:01. Right, that's 6. Yeah. Hit add. Oop. :01. There we go. Hit save. So at my corporate PCs, I could go back to my firewall rules now. Click on my default rule, go to my internal network firewall rules. And I could say, if the source is an access control list, my corporate PCs. So now I'm saying if my corporate PCs can talk to my server, anybody else cannot. So even if they're on the corporate network. It's kind of cool. You have these internal rules, inbound rules and outbound rules. DHCP guarding. Someone plugs a router. So DHCP guarding would be what we call trusted and untrusted zones, and we do support it, and we'll talk about when we get to the switches. So when we get to the switches, are the settings available for Peplink devices only certain models? Most of these selections are universal across all of our routers. Some of the content filtering, so some of these categories don't apply to all routers. They have two different categories. You have light and full. So some of the smaller routers that have smaller memory only get some of those categories, but otherwise it's pretty uniform across them all. Currently, we're just blocking. We're hoping that Peplink will add a page that tells you you're being blocked. Right now, it just simply blocks it. But right now, that's where we're at. Can you block specific OUIs? Not currently, we cannot block specific OUIs with MAC filtering yet. So in control is outbound. Most of Peplink services are outbound. And so as long as you're running outbound to in control, ac1.peplink.com and ac2.peplink.com, in control will still work. So you can deny all inbound and in control will still work as long as you're allowing outbound to peplink.com or ac1.peplink and ac2.peplink and rwa.peplink, or just peplink.com. And then on my rule here, if you notice on my SaaS, Peplink services is actually now a rule. So remote assistance, and they had SpeedFusion Connect as well. But if you want to allow it, you could add another rule and you could say peplink.com, destination domain name, peplink.com, allow, and just make sure that that's allowed as well. And I usually drag that up because I don't want it to get blocked. VLANs. So we talked about guest networks and VLANs, and captive portals. So I could create a new VLAN, and we'll call it the guest VLAN. And I could say VLAN 10. Apply this to all devices or some devices with the following tag: my mobile router. I don't want to create a guest VLAN on my hub router. I can give it a default IP address 172.16. Let's do 172.31.254.1, 255.255.250. Allow inter VLAN routing or block it. I'm going to say block inter VLAN routing because this is a guest network. I don't want access to my network. We'll assign it a captive portal label. And here I can do DHCP server. I can turn on DHCP, and it'll say the first 10 and the last 10 will be available. I can enable DHCP logging. My lease time, it's a guest network, so let's just say 4 hours. You could say assign DNS automatically. We'll just point it to the router, or you could customize your own DNS. Because we have a firewall policy for 8.8.8, we'll just do that. And then you could add your extended DHCP options, like your router, TFTP server, things like that. And then you have your DHCP reservation. So if you want to do DHCP name, MAC address, and static IP suffix, or you can do a CSV and paste a DHCP reservation CSV right there. Hit save. Now I've got my guest VLAN. So then I can go back to network settings and captive portals. I can make a new captive portal, and I could say Peplink University. And here we can access modes. I got social, so I can turn this on. I can do Facebook, X, LinkedIn, and Sina. Or I could do open access and just set the open access time-based data usage or time and usage. So I could say data and 5 gigabytes. Or I could do guest access, allow it, and actually create a guest accounts. We could do tokens and generate tokens, and then we could import those in to a receipt. We can do email, and we can authenticate with email. Now, this is kind of funny. So email is an interesting one because I had a customer that wanted a makeshift two-factor authentication on their network without a Radius server. So what we did is we turned on, created a captive portal, enabled email, and then we restricted the domain peplinkuniversity.com. So basically, unless you had an email address that was peplinkuniversity.com, you couldn't get on the network. So kind of cool. It gives you 2 minutes to check your email. So if you turned all these off and only enabled email authentication, I could say then portal at peplinkuniversity.com, and then set a daily quota, time-based, 5 hours, 250 minutes, whatever. Okay, and then allowed emails, Peplink University, and so you could add additional email addresses if you wanted to, and then that way, when you go to this VLAN, if I applied this to the guest network or to a business network, unless you have one of those email addresses, you're not going to be able to get on the network. So it's a way of kind of a poor man's Radius authentication in a sense. But for this purpose, we're going to do open access, click it, we'll say 5 gigabytes. Resets every day at 2 a.m. or after a certain amount of time, every day or after the quota is received. So the number of users a captive portal can handle would be based on the number of users the AP and the router can handle. So if someone asks how many users a captive portal can handle, unlimited users, you would be based on the APs. So depending on which AP you have, that's going to determine how many users per AP. If it's on a LAN network, then it'd be based on the router. So if you're doing this on a VLAN and you have 1,000 users on that VLAN, then just make sure you have like an SDX or something capable of handling the number of users. Then you can allow them into a network. So here you could actually allow them onto specific networks in your network. So once they connect, you could then allow specific networks. You can also create allowed access control list. So only corporate PCs that authenticate MAC addresses can use this. You can do Google Analytics tracking, redirect them to a page. Let's say peplinkuniversity.com. And then cache the splash page. Hit save. And there's my open access Peplink University captive portal. Then I can go back to my VLAN, click on my guest network, and I can choose the captive portal. Captive portal right there, Peplink University. And now captive will be Peplink University on that VLAN. Hit save. And that VLAN is only being applied to routers with the mobile. So now I've got a captive portal assigned to VLAN 10 on that. Now I can go to Wi-Fi, group-wide SSID settings, add a new SSID. I could say guest. Device selection on some devices, the mobile. open, I'm going to do layer 2 isolation, block LAN access, block speed fusion access, VLAN 10, and hit save. So now I have my guest network that's open, applied to my mobile device that will connect on VLAN 10 and have a captive portal. And so we just built a guest network with VLAN 10 on a captive portal. 1 second, boom. Can we use Peplink captive portal if we're using? So yes, what's cool about you can use the Peplink captive portal. So if someone asks, can we use Peplink captive portal using third-party APs? Because I'm assigning this to the VLAN, if those APs are on VLAN 10, anything on VLAN 10 is going to be come to that captive portal. So as long as I'm using VLAN 10 and a Peplink router, it can be even a ubiquity switch. As long as I'm trunking VLAN 10 up to my router, and then I have APs that are tagging VLAN 10, as long as VLAN 10 shows up, then it's going to connect on VLAN 10, and then you'll have the captive portal, because I'm assigning this on the VLAN level, not on the AP level. I assigned this SSID to VLAN 10, and that's the only reason why that SSID even matters. Sorry. I have if you were on my first one, I've got these sensors that shut off my lights. Okay, so VLAN networks, LAN network settings. This is advanced routing. I'm going to show it to you, but we're not covering, this is not part of the PCA. So LAN network settings, here you can configure static routes, virtual network mapping, DNS proxy, and modular forwarding centrally and in control. Once again, this is an advanced feature that is available, but not part of the PCA. Route advertisement, the same type of thing. You can turn this on and actually centralize your route advertisement capabilities of your group. We talked about captive portals just now, and then connection tests allows you to run performance analysis and monitor it. So say if you're the IT admin, you got 1,000 sites, and you're running all T-Mobile 5G SIMs. Give me 1 second. You're running all T-Mobile 5G. So I could say any of the following routers, my mobile routers, primary connection, cellular WAN, cellular 2, which is my T-Mobile. And then I could say do a speed test. And if the test fails, if it's lower than, download is lower than 10 megabits per second, and my upload is lower than 5 megabits per second. And then I want you to test every day at 6 a.m. So every day at 6 a.m., this router is going to run a speed test on cellular 2, and it's going to let me know if it is less than 10 megabits down by 5 megabits up. If it is less than that, the daily connection test report, you can then do a report in the settings, and then it'll send that out. And so that's going to give you the capability there to test your throughput, and you can then create multiple tests. So I could call this one cellular 2, and then I can clone this and say cellular 1, and say run that test at 6:15 a.m. save. And so it's going to test cellular 2, then cellular 1 every single day for me. And then I will then be able to go to my reports, connection test reports, and see these success and failures and the results of these tests. So kind of cool. And then we have the client list. The client list is going to show you who's on the network. So you can see my Pixel Fold is on my Wi-Fi right now. And so you can kind of see that there. I can click on my Pixel Fold, and I can see my daily utilization, how much bandwidth I'm using every single day. I've used 4.54 gigabytes. Tells me what router I'm connected to. I can get a vent log. It's a smartphone. I'm on the wireless network, MAC address, my IP address. I can see my signal strength. So there's my signal strength historically over time. So it's a great way to see like what's going on your network and what your clients are connecting. If they're complaining about performance, I mean, look at this. I've got all these details for signal. So obviously my signal here at -88, if I was complaining about choppy Zoom calls, it's going to be way different than right now where I'm getting a -47, right? And so that's really cool on the client list. Also on the client list, and I should plug another thing in here, but you can actually do actions. So you can add things to InTouch and from here as well. So kind of cool. I'll show you that later though. Now, so we're still on the group level, by the way. We haven't gotten to the device level. This is the group level. So now I can go to settings, device management. I can manage all my devices. So there's my head end and I can check these devices. I can go to actions. I can remove these devices, move these devices, change the map marker. I can push firmware, my Wi-Fi AP state. Oh, there you go. Look at that. Boom. Bulk turn off. Someone asked that question. Wi-Fi AP state turn off. So I can turn off my Wi-Fi AP on all my routers. I can enable DPI, enable remote assistance, hardware watchdog, download diagnostic reports. I can tell it to follow another GPS location, enable air monitoring mode, enable collecting Wi-Fi analytics data, lock my cellular WANs to the current active SIM card. So if I don't want them to fail over, I could lock them. Enable data roaming, update my cellular firmware, restore their factory defaults, remove GPS data, and then create per device custom SIM pools. So you have all that option. Then you can also create your tags. So I can add and remove tags as well. So settings, device management. Then I can add devices to the group. So I can put here, put in my serial number, select the tags I'd like to give it, and add devices. Device IP settings is for zero touch. It's part of our zero touch. So I can actually manage all my IP, all my LAN IP addresses, my subnets, my VLANs, how they're named, their IP addresses. So if I have 2,000 devices and I don't want to log into each device and set all my VLAN IP addresses and my subnets, I can actually create a master IP list here. It gives you a template. You just download the template file, and then it gives you a cheat sheet on how to configure it. Once you configure it, really cool. Device system management. Device system management allows you to control how the actual system settings of your routers. So here I could, like first PCI compliant, I could say this, Peplink University admin is my default admin username. Assign a random password to all my routers. Disable my read-only username, and I could even change the name of it just to make sure. Web session timeout. I can download a copy of my backup admin passwords. I can then set my authentication, local, radius, or tax. I can enable my CLI and console port. I can tell you how you can access the web GUI, either HTTPS, HTTPS, or HTTP, and then LAN or LAN WAN, what port I want to use for that, and what networks are allowed. So untag LAN or a specific VLAN, like VLAN 10 or VLAN something. So I could say you have to be part of a VLAN to access it. SD switch, same thing. You can set how it's accessible. APs, you set how it's accessible. You can set a password for your front control panel. If you have a balanced router with an LCD, you can actually assign a shared password, 1, 2, 3, 4, and lock the LCD on the router so you can't factory set it or change the default admin password. You can enable logging settings. So URL logging, session logging, send events to a remote syslog server. So if you're running like an SIM and you want all your routers to dump their logs to your SIM, boom, one checkbox. You add a router to InControl, and then it's going to automatically start sending URL, session, and event data to your SIM. You can also enable SNMP and NetFlow and send the NetFlow. So you have IPv5, IPv9, and IPFix. And once again, once you apply this at the device system level on InControl, every router in this group will get those settings. So you don't have to think about it. If you change servers, you build a new server, you don't have to log into 2,000 routers and change all 2,000 routers. You literally go here, change the destination IP address, boom, got it fixed. You can auto update your default SSL certificate on InControl or on Captive Portal. Highly recommend checking that box if you're using Captive Portal, and you can schedule reboots if you'd like to. So that's under device system management. Certificate management allows you to upload custom certificates. So if you want to use like star.yourdomain.com for your VPN, your web admin, your Captive Portal, or your Open VPN, you can actually centrally manage your certificates right here, and you can push them out to all your devices. InControl options. This allows you to configure how InControl how your device communicates with in control. So literally you can go into device, you can disable configuration, you can disable firmware management, you can enable low usage mode. And you can see right here, it tells you the estimated usage. So if I enable low usage mode, it's going to drop the utilization to 1.3 megabytes per month without GPS data. And so you can configure how in control is used. Notifications, it will send you, it creates notification profiles. You can have multiple profiles. So if you need to have multiple different types of notification profiles, you can do that. And then inside the profile, you can figure out how in control is going to notify you what's going on in your network. So I can say show devices with the following tags: mobile, silence period, Saturday from 12 a.m. to 11. I don't want to be notified on Saturday and Sunday, and then Monday only notify me from 12 a.m. to 6 a.m. Monday through Friday. So it's gonna silence during the day there. And then you can email notification. So I can click this and literally get notified on all these different options: device offline, device starts up, HA transitions, WAN up down, Starlink, high system temperature if it gets too hot, if there's an error with Starlink, Speed Fusion up or down, Speed Fusion Connect. I mean, literally all these options. You can get an email notification. You can literally get if a LAN port goes up or down. You can say, if someone plugs into my LAN, I want to know about it. Check the box. Now, right here, especially if you're part of somebody else, this is a public service announcement. Don't just leave this all organization group members. If you're getting 10,000 in control alerts every day, it's like Boy Who Cried Wolf. They're just going to delete, and they're not going to read them. Make sure your events mean something. This is why we offer multiple different groups profiles. If you're the security admin, go to other email and just put in security@domain.com. Or you could say group admins, like the admins of this group get notified. When you say all organization and group admins, it literally is going to send to everybody that's in the organization or the group, whether they're relevant or not. And so you might be spamming people's mailboxes. So pay attention to who's receiving these, because if you overwhelm them, they're just going to start ignoring them. And then they're going to be like, oh, I didn't know that went down. Wait, what do you mean? Oh, I created an Outlook rule to send all in control notifications to my in control folder. Oh, great. Now it's not being read. And so the whole purpose of a notification gets mooted out by spamming your employees or your teammates. Report emailing is different than notification. Report emailing is going to send reports. We talked about reports on the organization level. Now we have reports on the group level. So we have device reports, Wi-Fi reports, usage reports, CAF reporter reports, and connection test reports. And we can literally send whether those daily, weekly, or monthly. So you can say every day, send me my connection reports, right? And send it to, once again, maybe report admin@domain.com or whatever. Firmware policy. Firmware policy lets you push firmware to a router. So you could bulk configure firmware. If you want to enable beta firmware, you can actually show beta firmware. Scroll down, click I agree, and then you'll see the latest beta firmware right there. You can choose whether you're going to do this immediately, scheduled, or based on geofence, which I'll talk about geofencing in a second. Schedule allows you to say, hey, I want to make sure we push firmware on Friday at 11 p.m. and offset them all by 5 minutes. And literally, it will then push the firmware starting 11 p.m. on Friday, 5 minutes segregated from each other. And it will then push the firmware to your router. So if you have a maintenance window and you want to push the router firmware from that maintenance window, you can. Or you can say when it enters a geofence. So say you have a fleet of police cars. You don't want to push firmware to the police car that's out in the middle of the field at 11 o'clock at night and he's the night guy, right? You want to make sure it only pushes when they enter the yard. So you can create a geofence, which I'll show you in a few seconds. And then you create a geofence called fleet yard, and then say, push this latest firmware when they enter the yard. They drive into the yard, boom, the firmware gets pushed. Device schedule we talked about already because we use that for Wi-Fi. Geofencing. So geofencing, we can create a geofence. We can call it Fleet Yard. I can add a circular area by CSV upload or a path. So I can create a circular area just because it's easy. West Networks. Let's see if that'll. Oh no, well, that didn't work. Anyways, click on a spot, draw a circle around it, call it Fleet Yard. Hit OK. And then there's my spot. And I could say all devices, email notification, email me when I enter or leave the zone. I can do HTTPS push alerts. I can turn on or off my Wi-Fi. So when I'm entering the zone, I could say disable, enable on leave, disable on enter. So when I enter the zone, turn off my Wi-Fi. When I leave the zone, turn on my Wi-Fi. I can apply a tag and I can say at yard. Oops, sorry, you can't have spaces in a tag. At yard. So literally, as I pull in, it's going to add a tag at yard. So if you're doing notifications based on tag, and then I could say apply firmware. Let me turn this off. Hit save. So now I've added this. I can go back to my firmware options, and I could say enter geofence. Yeah, save that. Is that not apply firmware? Firmware policy. Enter yard. Maybe I got to save it. Anyways, create a geofence. Geofence. I did create a geofence. Apply firmware. I will have to figure out why that's not showing up because I'm supposed to be able to go. And then when I choose the firmware, oh, you should just, okay, apply firmware, which I did. Okay, so then you just hit save changes and it'll do it when you get to that location. I apologize, guys. I don't use that particular one very often. Bulk configurator is another one of the zero touch. I don't use this as much anymore, but bulk configurator is the ability to basically configure one router like a BR1 mini and then push that same exact configuration to hundreds or thousands or tens of thousands of routers at one time. And it just basically ensures that they're all running the same configuration. I like to use the zero touch features here, the IP address manager and all these functions. But some people do use that feature. I just personally don't. Ad delivery service is not part of in control that you would know about, and you won't have it unless you have the ad delivery service. So we'll ignore that. That's not part of this test. And then group settings. This allows you to add group users. We talked earlier about the organization users, but if you have an admin that's just part of this network, you can add people just giving them access just to this group. So you don't have to add them to the whole organization. So you can have group level and organization level. Time zone, you have display and notification capabilities and what they're allowed to see and do. Whether or not they're allowed to use the Peplink app, what the map markers look like. It's the default address for this location, for this group. So you can do that right there. And then you have your operation log for the group. And you can see group-based operation log. And this is, by the way, new feature. So that's the group level. So then we can go into our device level. I know that was a lot, guys. I mean, that took a while to go. In control is a pretty intense. So then we go into our device level. And on the device level, I can start to see the router here. I can see my AT&T, my T-Mobile, I'm on my Wi-Fi. I've got two SIM cards right there. You can see I've got A and B SIM card. I can switch to my B SIM card if I want to, right here. And so you can see that you're connected. I can see there's my guest VLAN that we created. It's right there. I can see how long the router's been online. I can see my feature activation. If I click show all right here next to my device name, I get my IMEI. I can see that I'm on 5G. I get the full product SKU. So it's a 5GH router. My supported SSID is 16. My SSIDs, you can see, look, I've got my Peplink and my guest. And so I click on my Wi-Fi, which obviously I'm not going to click it, but there's my guest network right there, which I'm not going to do. We're on a call. And then there's my radio frequencies. And then look at this, configuration backups. I can click download and I can see every time I've changed this router configuration, every time in control made changes, I can download a copy of my configuration or I can revert back. So if I go, oh man, I goofed up yesterday, let me revert back to last night. And I can just apply that configuration file right from here. And literally the router will just take that configuration from January 19th. And you can see right there, web in control, web admin made a change. So it tells you where that change is made too, if it's available. In control, web admin. So it's right there. I can also download diagnostic reports. I can see my expiration date. So you see on February 8th, it's expiring. So I'll renew that tonight. I can see my firmware version. I can see my CPU load, my usage, my clients, my speed, which is a little misleading because I'm not moving, I'm sitting still, but my speed, my location and my altitude. I am in a building, so maybe it's the GPS is hopping around. So my reports now are going to be based on this device, not based on the group. So now I'm going to get device reports of this device, Wi-Fi reports of this device, DPI reports, which isn't available in the group settings. It's going to be local DPI reports, WAN quality, and then bandwidth and usage. And I want to show you the difference between bandwidth and usage. Now I get real-time usage. So I can do real-time, per minute, hourly, daily, and monthly. So I can watch this bandwidth in real time. And you can see, I was waiting to show you that. So I'll answer that question. And I can see the usage in real time. I can see the usage per minute, and I can use my hourly, daily, and monthly usage right here. I can then go into my WAN quality report, and I can actually see the quality of my internet connection. You can see right here, I can see my AT&T quality over the last 10 minutes, 30 minutes, and hours. I can do my WAN 2. So if someone calls and said, hey, I was having a problem last Thursday, and oh yeah, look at that, look how crazy that was, and you can see, that the channel 925 had poor signal, and you only had good, you didn't have excellent, so you can look ups and downs, and so the network was going crazy last Thursday. And so you can look at that right from this WAN quality reports. And you can look at, there's my AT&T, my T-Mobile. I can look at my Wi-Fi WAN if it was working. Nope, not working. So you can see that stuff right there. Bandwidth and usage, captive portal reports, which we'll be able to look at once I connect to it and use it. You have your event log, your firewall log, your connection up and down history, and then your air monitor reports. Here, you can only see the status of SpeedFusion. There's no configuration on the device level. You do that on the group or the org. You cannot configure SpeedFusion on the device. So here's my status. You can see my 3 SpeedFusion tunnels, which connections are being used, and you can see that they're connecting to the head end. So I've got my tunnels, and you can see that they're established, and you can see cellular 1, cellular 2, and my Wi-Fi WAN is being used. And there they are. Wi-Fi is the same way. You can see the status of it, but you can't. You can change the radio, but then you can't. But that's going to be the local device. And then the SSID, you have to go back to the group, is what I was trying to say there. And then network settings. You have your outbound. Oh, I went back to group. Sorry. There we go. And then clients. It shows you the local clients to this device. So you can see there's my Pixel Fold, and then you have this InTouch button. So say I have a Netgear switch, and I want to manage that Netgear switch. By the way, this is a real use case. I had a customer that a client was complaining that their guest Wi-Fi network wasn't working on VLAN 5. And so they could see they had the Peplink AP and a Peplink router. And I was like, well, how's that AP getting power? And they said, oh, we have a Netgear switch providing PoE. I was like, do you have VLAN 5 programmed on that Netgear switch? They go, no. Or no, I don't know. We just plugged it in. So we went to the client list, found the Netgear switch, clicked InTouch, remote controlled the Netgear switch. It had never been configured, used the default password, logged in the Netgear switch, created VLAN 5, trunked VLAN 5 on all the ports. So VLAN 5 trunked up, and boom, his Wi-Fi started working. So InTouch gives us out-of-band management into any of our devices. So kind of cool. Then we have our settings. This is a remote web admin. It lets us log into this device remotely, which I'll do a full tour of that in a bit. We have our InTouch, so you can go to InTouch and configure InTouch. So here you can do serial port management, or you can do IP-based. And in IP-based, you have HTTP, HBS, SSH, Telnet, RDP, and VNC. So you can literally VNC into a PC. I put the IP address and the VNC password and access it on a web browser. And then we have our web command line. So you can log into the command line of the router. Firmware management, certificate management, and then device tools. Device tools is really cool. So in device tools, you can run a ping, a trace route, eSIM activation, eSIM deletion, WAN performance analysis server, remote assistance, reboot, and factory. So eSIM activation, I can come in here, eSIM activation, choose my cellular, input a code, post the code right there, and hit submit. And it's going to activate an eSIM. Then I can go to eSIM deletion. And if there are any active eSIMs, it will then show me these and I can delete them from those profiles. If you need the EID, you have to be running 8.4.1 firmware. Go to your cellular modem, cellular 1, scroll down, and you will see maybe it's not on any control yet. Hold on a second. Cellular 1, click on this. EID right there. There's your EID. So you click, go to remote web admin, click on the little IP address, and then you can grab your EID. I can then take that EID, give it to my carrier to register an eSIM. They'll give me a code, and I can put that eSIM under device tools, eSIM activation, and then activate. Or if they give me a QR code, I can click scan. It'll bring up your camera, and you can scan the QR code and activate the QR code. So really easy. And once you have an activated one, you can delete it. WAN performance analysis server, I'm going to show you that during module 4. Remote assistance. If Peplink needs remote assistance, you can say, hey, turn on remote assistance, go to settings, device tools, remote assistance, and turn it on. You can reboot the router and you can reset the factory defaults. Whew, that was a lot, guys. So that is the group, the organization, the group, and the device level in control overview. Some additional in control stuff. Once again, you can click the notification icon to see the changes. You can click on your name in the top right-hand corner, and you can set your own profile. So you can see your logins, you can set your name, you can set your language, you can change your password, you can enable 2FA. Guys, we're network people, we're logging into routers. We have the ability to remote control switches and devices on your network, enable 2FA. So you just enable that, scan the QR code on your authenticator and put in the code. You have application control. Client applications have access. You have your API accesses there as well. But set up 2FA, and then you can see those settings. I think I covered everything on it. How does the licensing work with InTouch? InTouch is based on Speed Fusion Connect and your Prime Care and or Essential Care. So you have to have the router with that's capable of Speed Fusion Connect, and then it's based on that. So as long as you have an active router with an active Prime Care or Essential Care, you don't have to have Speed Fusion Connect enabled. You just have to have it available, and then you'll be able to use InTouch. Okay, so that's that. Okay, let me go back to this real fast. So InTouch, I kind of talked about it a little bit, and I will demo this as well. I'll set up a lab for the next one. But so InTouch, we can configure anything from anywhere like you're there. So basically, if you have a Peplink router or a Peplink switch, this works on the switches now with 1.31 firmware. You can literally out-of-band manage anything that has an SSL, an HTTP, VNC, RDP, Telnet, or SSH. That's accessible on IP address. You can even access things that are not routable. So you can access things on a specific VLAN as well. And so the idea is you have an NVR or some switches. You have maybe a Cisco switch stack or a Netgear switch stack, and you want to manage that, and you don't want to have to log into a different platform. You can right from in control manage that. I've also just mailed people BR1s with a SIM card in it. Said, hey, plug this in your network. Remote control, and I can fix switches and things like that remotely. Just mail them a router, and I just log in with InTouch. Um, so, InTouch eliminates the need for engineers, VPN servers, or extra software. Typically, the need to manage your devices. So from in control, you can now manage all of your devices from one ecosystem. Additionally, there's no public IPs or firewall rules to be open. So you're not saying, hey, can I enable SSH into my network? No, there's no firewall pools. You can deny all in and out, and this is still going to work because it's happening on the Peplink router side, on the it uses SpeedFusion Connect. So you don't have to open up firewall rules to make this work. It basically, as long as the Peplink can ping that IP address of the device or serial port RS-232, you can then just RS-232 bring up the console and access the device. So there's no firewall ports needed. It's all done in control. It's very, very nice and convenient. Can't. There we go. A typical out-of-band management, you have to you're VPNing or connecting into a out-of-band management server, and then you access your routers. With InTouch, you're just logging into InControl, so it just uses SpeedFusion Connect and InControl, and then device, and so there's no primary ISP or backup ISP or anything like that. You just InControl and you connect. Thank you for staying around. I mean, we've only lost like 10 people through this session, so thank you so much for listening to this and listening to my voice. You guys have got to be sick of it by now, and I appreciate you guys sticking around and taking and watching me do this. So what's really nice is I used to have to do 2 demos. I had to demo the balance route in UI and the Max UI. With 8.4 or 8.3, they unified the UIs. And so now you have a unified infrastructure for the user interface of the router. There you go. See, someone just set it up. They logged into their printer via on site via OneTouch or InTouch, and not OneTouch, InTouch. So, so now we have a more unified experience here, and so that's going to be really nice because whether you're running a balance or a Max router, you're basically on the same stuff with just different interfaces. And with Synergy, you actually even get the same interfaces. So the dashboard of the router, I'm accessing this via in control, but if you just go to like 192.168.1.1 or 50.1 or whatever your router's interface is, you can log in, and this is what you'll see. This is what we call the router dashboard. So don't confuse that with the in control dashboard, which is what you just saw. On the router dashboard, you're going to see your WAN connection priority. And someone had asked a question earlier: is priority on outbound policies different than priority on WAN connection status or the dashboard of the router? And so this is really, really important. This is the status of the interface itself. So if I drag Wi-Fi WAN down to priority 2, well, hold on a second. Let me go to status of my SpeedFusion. And you can see there, cell 1, cell 2, and Wi-Fi WAN. They're all connected, and you can see traffic is traversing them all. So if I go back to the dashboard and I move this connection to priority 2, and then I go back to status, look, my Wi-Fi WAN is not being used anymore. Standby, lower priority. So when I manipulate the dashboard priority, it's in control. Outbound policies and SpeedFusion can't use those unless AT&T and T-Mobile both failed. Then the Wi-Fi 5 gigahertz would kick on. And so it's important to know that this is your interface status priority. if a connection is not active here, it's not active anywhere. It's not active in bonding. It's not active in outbound policies. It cannot be used if it's not active here. So I tell people, if you're looking for the highest resiliency and the highest failover and reliability, you need to have all of your connections green here, then use outbound policies and speed fusion priorities to make sure that that connection is being used or not used. But don't, if it's off here, it's off everywhere. So this is priority or interface status. And it's going to work top down. So if I have cellular 1 and 2, and then the Wi-Fi down here, cellular 1 and cellular 2 have to be off before this will kick in. Now, there is a way, for example, cellular, I could do with cellular 1. There is a test question that says, actually, that doesn't look that bad. I got this light. I have a light on because my lights keep turning off. So let's say that I want the Wi-Fi WAN to be on, even if these two are in a higher priority. I could actually go to cellular 1, and I could say independent from backup WANs. Save and apply. Cellular 2, independent from backup WANs. And there's a test question, and I don't want to cheat on the test question, so I'm just going to show you this. Now, cellular 1 and 2 are independent of priority. They're just always going to be on. And now you see my Wi-Fi is in a priority. So if I plugged into the Ethernet, this Wi-Fi would turn off, but these cellulars are always going to be on regardless. And so they're not part of the priority. They're independent of the priority. And so now they're all three are green. So that is a test question. And it gives you a use case scenario about it. Then I have my LAN interface. This is my untagged LAN interface. And a lot of people ask about the management port and the basically the management port. That's based on the untagged LAN. The untagged LAN is basically our default VLAN or native VLAN. So that's what the router is going to have. You notice I pushed VLAN 10 to this router, but that's not showing up here. This is my LAN interface for the router. Is this 192.168.50. Then I have my two Wi-Fi's using my guest and my Peplink backpack. You can see my 3 tunnels: dynamic weighted bonding, WAN smoothing, and TCP with that dynamic weighted bonding. I don't have SpeedFusion Connect active, but you can see that I've got 597 gigabytes, and it expires on February 8th. And then you can see Peplink eSIM pool data of less than 1 megabyte. So I actually bought some Peplink data at one point for a demo, and so I used it all up. And then I have my device information. So I've got my firmware, how long it's been online, my CPU load, and my throughput. It's all right there. Then I can go to SpeedFusion Connect. SpeedFusion Connect is Peplink's public bonding service. It must be managed locally on the router right now or using the SpeedFusion Connect app. There isn't manageable in control yet. So I have client mode and relay mode. Relay mode is, let's say you have an RV and you have a streaming service through your local cable provider, and you can't watch your TV when you're on your RV because it says you're in North Carolina instead of Florida. Well, you can put a Peplink router at your house, enable relay mode, and this can be behind a NAT. This is using SpeedFusion Connect. Doesn't need any public IP addresses. It uses SpeedFusion for it. Choose my location. So I could say Dallas. That's probably my closest one. Hit OK. And it's going to give me this code. Copy this code. Hit save. And then I can go to SpeedFusion Connect again. Client mode on the client router. So I put that on my primary router, and now pretend I'm on my client router. So I was on my 20X, and this is on my BR2. And then I can say relay sharing, put in that code, and now my 2 routers, my home router and my RV, will connect. And now I can say, hey, send my TV through to the 20X, and now my router's sitting at home on my cable internet. My TV thinks I'm sitting there. So now you can watch your TV screens as you're traveling around the country, as if you were sitting at your house in Florida, which I live in Florida, so that's why I choose Florida. Most people won't use this feature. Most people use our client mode feature. So let me just revert this real fast. There we go. Save. Okay, so most people just want to use Peplink's cloud service. So you can go to client mode. It says for outbound access. And here you can choose automatic, or you can choose a destination like Atlanta, Chicago, Dallas, or Europe. So I could choose Toronto, and I could choose Atlanta. You could choose up to 3 locations. This is a test question. You can have up to 3 locations. There we go. So Sydney, Atlanta, and Toronto. And now I can configure these, and each one of these can have 5 subtunnels. It's a test question. 5 subtunnels, 3 SpeedFusion Connect locations. And so once you're in this, I can configure my options. So I can create my subtunnels. Like I could click plus, and I could say WAN smoothing, and then I could enable WAN smoothing. And here I could name this one dynamic weighted bonding, and just have dynamic weighted bonding. And then I could have this one say FEC and turn on forward error correction, and then hit save. And now I'd be able to hit apply changes. And those 3, 4, 5 tunnels will be created now under SpeedFusion Connect. And I'll show you those when they come up. So then under the network tab, we configure our LANs. And you see the gear. It's an in control managed input. Settings can now be configured in control. And you can see the gear. So my in control is pushing the these LAN settings. So if I change these settings, I can change them. LAN settings can be changed. No, they can't. They'll be overridden. So if I change anything here, it's literally going to be overwritten within control because the gear's there. But I can create a new one, and that would not be overwritten because that's a new one. That's what I meant to say. So there's my static routes, my virtual network mapping, my DNS settings, and my bonjour settings, all under the network settings tab. You can't get a static IP through SpeedFusion. Oh, well, SpeedFusion Connect relay, you can use your home static IP. Yes. Yes, with relay, you can get your home network if you have a static IP there. But then you don't need a relay. So relay, the whole purpose of relay or SpeedFusion Connect is you don't have a public IP. If you have a static IP at home, then you should just use regular SpeedFusion like I'm doing with my head-in unit, because then you have a layer 3 network. And you can do port forwarding and NATing and all sorts of cool stuff. SpeedFusion Connect is really because you don't have a public IP. And then on our port settings, because I have VLANs here, so I can go to my port settings. I could configure port 4 to access my guest network. And so that's like if I had a third-party SSI, like a Netgear PoE switch unmanaged and a AP from somebody else, I could access this to VLAN 10, literally plug in any switch and any AP untagged, and it's going to come in as VLAN 10. It's going to get my captive portal now. So I don't have to have any port trunking or anything like that. If I just wanted the whole thing to be untagged, I could access VLAN 10 there, and literally anything that plugs into that port is going to be VLAN 10 on the router. Let me go back to dashboard and see that's connected. I just wanted to, while I was waiting for that to connect. There we go. So now that all those are connected, you can see there's my Atlanta. So my dynamic weighted bonding, my WAN smoothing, my FEC, there's my Sydney and my Toronto. And so those are all connected and established. Now, on the WAN settings, I can go to WAN 1. These are my Ethernet port settings. So I have the ability to set my priority, independent from backup. We already talked about connection method. I can do DHCP, static, PPOE, L2TP, or GRE. So I can choose a GRE as that Ethernet interface, L2TP for that interface, PPOE for that interface, static IP address for that interface, or DHCP. If I do static IP address, you could technically do on DHCP, but if routing mode is by default NAT, if I want to do IP forwarding or routing, I could actually click the question mark, enable IP forwarding mode. IP forwarding will route the traffic out that instead of NAT the traffic. So if you have a public IP address with public IP addresses on the LAN side and they're doing a CIDR and you want to have public IPs through it, you could actually have your LAN as public IP space, your WAN as a public IP point-to-point address, and then enable IP forwarding and not NAT that traffic. That way your LAN is a public IP going off to other devices, like a DMZ or something like that. And then here you can, when you do IP forwarding, you can NAT remote SpeedFusion VPN peers, or you can use the default LAN IP address for internal services. So you have the ability to check those boxes right there. One of the things that you should remember is these question marks are not just for help. A lot of times they give you features. Like, look, to configure a management IP address, click here. Like literally, boop, their management IP address. They're not, the question marks aren't always just to help. A lot of times there's a feature that's hidden inside the question marks. Then you can set your speed, your DNS settings, your physical interface settings, your health check. The health check is how the Peplink knows whether that connection is good or bad. If the health check has failed, it's going to say it's failed, and then it's going to use the lower priority interfaces. So we want to make sure that you can do DNS, ping, HTTP. If you do DNS specifically and you don't pay your bill, a lot of times the DNS still works. So that's a false negative. You won't have, it'll say the connection's good because DNS is working, but once you try to browse the internet, it takes you to their, hey, you forgot to pay us bill page. And so sometimes it's a false reading. So sometimes if you have more than one internet connection, we'll do HTTP and say like www.google.com and www.bing.com. And then, I mean, if both of those sites go down, then we've got bigger problems. And then basically it's going to check to see if you can access Google and Bing. If it can't access Google or Bing, it's going to mark it as failed. That's, kind of I didn't pay my bill. We cannot do health check based on bandwidth speed available. And the reason is because in order to do that, you'd have to be on a speed test, which is going to consume all the internet. So you'll never have internet because it's checking based on speed available. So there's sort of a catch-22 there with available bandwidth. You basically have to do a speed test using all the bandwidth to check how much bandwidth is available. And it just doesn't make logical sense. And then you can do timeout, your health check intervals, and your health check retries. And you can do a bandwidth allowance monitor. So say your cable provider gives you 1 terabyte of bandwidth per month, you can say 1 terabyte, boom. And then on the notification options on in control, you can say, warn me at 95% utilization. You see, so email notifications, 75 and 95. So if you only get 1 terabyte on your cable connection, it's a gigablast with 1 terabyte, then you can be notified when you're using up that bandwidth. Cellular is a whole bunch more options than Ethernet. Ethernet, you have that. Cellular, you get a bunch. You have 2 different areas to go to. You have the left and the right. On the right-hand side, you're going to get all your interface settings. So you're going to see your IMSI, your ICCID, your mobile telephone number, your EID, what I'm connected to, AT&T there, my band that I'm used to, my IP address, how long it's been connected. On the left-hand side, when you click on the actual interface, this is where you're going to get all your configuration options. So you're going to have the ability to set up all your WAN connection settings. They're the same as the Ethernet. And then you have your cellular settings. If you notice here, we have SIM A, SIM B, Remote SIM, Fusion SIM, and PEP SIM. If you add a SIM profile, like another eSIM, it'll say BYO, bring your own eSIM 1, bring your own eSIM 2, bring your own eSIM 3. Well, if you notice here, you have SIM A and SIM B, and you have your 3G, 4G, your band selection, your authentication, your operator settings, but you only have SIM A and B. There's a little scroll ball. There's your Remote SIM, your Fusion SIM, your PEP SIM, and if you have additional eSIMs, you can scroll left and right down here and configure each one of those SIM cards independently. Let's say you have 2 T-Mobile 300 gig plans and SIM A and B, and you want it to fail over from SIM A and B based on 300 gigs. I can check this bandwidth allowance monitor, and I can say, I've got 300 gigabytes of data, disconnect when it hits 100%. Oops, sorry, 300 gigs. So what's going to do is it'll use 300 gigs, fail, and kick on SIM card B until it has 300 gigs. Boom, 300 gigs. And then fail. So now I got 600 gigs over 2 $50 plans. I can also set an acceptable threshold. So say I have T-Mobile and AT&T, and I want to say, hey, in the event that AT&T is 3 bars or less, go ahead and try T-Mobile. So it'll actually fail over. And if neither one of them, will say failed acceptable level. It'll say, hey, your acceptable signal strength is not good enough for what you want to have. And so it's just going to shut those SIM cards down for you. And then you can set your MTU and your interface settings, and then your health check. Smart check is an option only available on your cellular connection. So you have ping, DNS, HTTP, and then smart check. Smart check is a mix of connections designed to lower the the consumption to keep your connections alive. And so it's just a little bit healthier health check for cellular connections. Wi-Fi WAN. So Wi-Fi WAN, you're going to get this little symbol to the right. Wi-Fi WAN, you can click on this and it'll show you available Wi-Fi networks, and then you can connect to those Wi-Fi networks. If you need to create your own custom profiles, you can click on the Wi-Fi WAN, scroll down, and actually add your profile. So I can say create profile. Hit OK. And now I've added a new oh, I already had that one there, but now then it'll connect to that profile. Or if I type my password wrong, I can click and then click on this and then change the password. I've been asked multiple times, how do you connect to like a Wi-Fi network that has a captive portal? The easiest way to do this is, let me, hold on one second. Let me turn this thing off because it's not going to work. Boop. So the easiest way to connect to a Wi-Fi network that has a captive portal is to first connect to the Wi-Fi network. So say you're connecting to Starbucks, connect to Starbucks. Then drag cellular 1 and 2 down to a lower priority, priority 2. Now, because Wi-Fi WAN is priority 1, go to google.com, you're going to get the Starbucks sign in. Sign into Starbucks, put in your, say okay, then drag cellular 1 and 2 back up. Now you have your connection established and all 3 of them are there. And so you'll be able to then utilize that connection. So that's the easiest way to do it. There are more complicated ways, but I think for a PCA test that works. Let's see. I want to say I got to go in routers with SIM A and B, same modem. Does it work as a no? You can't hot failover SIM A and B. So SIM A and B is going to disconnect and then reconnect. And usually it's like 60 seconds because it's got to authenticate and negotiate with the carrier. So if you want hot failover, it has to be active WANs. So anything that's not active cannot hot failover. Possible get through splash page captive pollutant using Wi-Fi WAN. I just answered that, I think. Boop. Okay. So there we go. Okay. Yeah. WAN settings, Wi-Fi WAN, Wi-Fi. Okay. So advanced is where you configure everything in the router now. So we've got our WAN set up, we've got our LAN set up, we got our VLAN set up, we've got our access port for our trunk. So our network is up. Now we can configure all the cool stuff. So we have our SpeedFusion configuration. We can configure IPsec VPNs, GRE tunnels, OpenVPN, outbound policies. And once again, I have everything managed in control. But if you want to do it without in control, you just click add rule. If you're on SpeedFusion, if you want to do it in SpeedFusion, I'd have to disable to show you, but you just click add profile, and then you can manually set up the same policies and in control that you do on the router. And I'll show you that later. Port forwarding. So if you need to do port forwarding, you just go to port forwarding and you can set up your port forwarding rules. So I can add service, and I could say SSL, web server, web 1, and I could just choose HTTPS, and I could say WAN 1, WAN 2, or even a SpeedFusion VPN in that mode if I'm giving a public IP address, which you could do. It's kind of fun. So you can actually give a LAN, public IP address, as we already talked about that, on your hub device, then enable NAT mode and literally assign a public IP address to any Peplink router anywhere in the world as if it was right there. And it's a NATed public IP address to your router. And then you just put in the IP address of the LAN device, 192.168.50.10 or whatever it is, and hit save. Oh, WAN 1, WAN 1, boop. And then voila, there you go. You're port forwarding your your WAN IP addresses on 443 to that server. You do have to have, if you do port forwarding, you need to make sure you have the inbound firewall rules that allow that same traffic. Yes, WAN settings. So somebody asked about DNS settings. WAN settings are local to the router. So you do have to configure those locally. If you have lots of routers, that's one thing where the bulk configurator might help you. Like if you wanted to push the same WAN settings to a bunch of routers. But the WAN settings are per router. That's the kind of one limitation currently to InControl. NAT mappings. If you want to create a NAT map between a public IP and a private IP, just WAN interface, boom, WAN interface, boom, put in the IP address, 192.168.50.10, like I did earlier. And now everything on WAN 1 is going to go to 192.168.50.10 inbound and outbound. And this really is important if you have multiple public IPs and you want to NAT something like a firewall behind it or something. Edge computing, we're going to talk about later, but you have application and Docker support on the BR2. On our more powerful routers, you can actually set up like servers and stuff like KVM hypervisors and whatnot. QoS in 8.4, we now have the ability to have 10 QoS groups. Yay! It's been a heavily requested feature. So you can now have up to 10 QoS groups, and you can name those, guest, VLAN, corporate users, Wi-Fi users, phones, etc. Then you can apply clients to those groups. So you could assign like a subnet 172.16.50.0/24 goes to, I didn't save, goes to the VoIP VLAN or the guest VLAN. And there it is. Sorry, if you hit save, you could do that. Once you do that, there you go. Okay, once you do that, then you can go to bandwidth control, individual bandwidth limits, and you can actually set individual throttling limits to each user on a VLAN. So I could say my guest VLAN gets 10 megabits per second down by 1 megabit per second up, but this other guest VLAN gets 15 megabits down by 5 megabits up. You see, and so you can set throttling limits to users of the different groups. We also support bandwidth reservation. Bandwidth reservation only works for the top 3 items, and so that's a test question. Bandwidth reservation is only going to be on the first 3 QoS groups. You can't do reservations for all the other groups, but you can do limits on the other group, but not reservations. And then application queue allows you to assign bandwidth to an application. So I can create an application queue. I can say 10 megabit per second, and I could do upload, download, 10, 10, and I can give this a high priority, hit save. Then I can go to application, add an application, video streaming, all supported streaming, give it my high queue at 10 megabits per second. So I'm gonna say, hey, I want my video streaming application to basically get prioritized 10 megabits per second. This is really important, especially if you're doing like a 1080p stream or you're doing broadcast. You want that 4.8 megabits for your 1080p, and you want that to be solid against if someone's downloading something online. You can assign that 5 megabits per second to the application, and that application, that video streaming application, is going to get that 4.8 megabits that you need. Firewall is the same that I did in InControl. It just applied locally. So there's your rules: outbound, inbound, internal, intrusion detection, local, and then there's my content blocking. And you have your application blocking, your database. You see how this one has less in it? The BR2 has a less categories. So only the categories that are supported. Exempted user groups. The only thing missing from this one, if you go to like add outbound rules, the destination is only my IP, my network, and my domain name. I'm missing the access control list, the group network. Well, if I added a group network, it'd show up, but I'm missing the SAS and the region. The SAS and the region are InControl features. So SAS and region are going to be limited to InControl configuration only, not router configuration. Then I can go to my routing protocols, OSPF and BGP. So if I look at OSPF, I have a SpeedFusion tunnel. We by native use OSPF, and there's my 000 with my SpeedFusion VPN. I can select which networks I want to advertise. I don't want my guest network advertised, so I can uncheck that, do untagged LAN, hit add, and now only my untagged LAN is being advertised over the tunnel, not my guest network. Once again, isolating that network. I block LAN access, I block VPN access, I did layer 2 isolation on the SSID, and I can further say, I don't even want that subnet advertised over SpeedFusion. That guest network, it can go out the internet, but it can't do anything else. I can do that right there. And then you have your static route advertisement and your custom route advertisement and your excluded networks. And so you can customize how OSPF is kind of propagated through your network. BGP, Advanced Routing Protocol, not covered under the PCA, but we do support it, and it is here. And I run BGP on my WAN infrastructure. It's really fun. Remote user access. We support L2TP VPN, PPTP VPN, and OpenVPN clients on the for remote user access as an inbound VPN. You choose your you choose the protocol you want to use, select the interfaces you want to receive the connection on, and then you can choose which VLAN you want those users connected to, what protocol, what port you want, and then you can create your user accounts right there. And you see, you can include OSPF throughout. So if I want them to have routable access on that untagged LAN and have OSPF, I can do that as well. And that's going to allow someone to VPN network and then, access your infrastructure if you need to. Almost all modern routers, Peplink routers support HA now, VRP HA. HA is deployed by pairing 2 routers. They use VRP on the untagged LAN. So if I see if I can pull this up real fast. HA. So if you have 2, I don't like that one. Let me make this a little simpler. Hold on. So if I have 2 routers, 2 SDXs, and I want to do HA, the primary router, is going to be, is going to have like a 192.168.1.2. The secondary router is going to have an interface of secondary 192.168.1.3. Then the router is going to share what's called a VIP or virtual IP, and that's going to be 192.168.1.1. It's my default gateway, my default network, 192.168.1.1. Then if you have a switch, so the 2 routers will plug into the switch on the LAN, boop, boop, like that. They can then go out to the internet. So if I have an internet connection, so we'll have 2 internet switches for WAN 1 and WAN 2. So WAN 1 goes up to the ISP. This goes to WAN 1. This goes to WAN 1 on this router. This goes up to the ISP. And then this goes to WAN 2. And this goes to WAN 2. So I'm taking that ISP input, ISP 1 and ISP 2, splitting that, and then plugging into both routers. The WAN IP address on both of routers is exactly the same. So if I go WAN 1 is public IP 1, I'll say A. WAN 2 is public. Oh my gosh, I can't type. Public IP B, control AC. They're the same. So WAN 1 and WAN 2, IP A and B are going to be the same. If this router fails, basically what's going to happen if this router fails, the secondary router will pick up 192.168.1.1 on the LAN. It'll maintain 192.168.1.3. That's its heartbeat IP address. And they're connecting through this switch that's maybe 192.168.1.4 or something, 192.168. So they're talking together through this switch on the LAN, and then the switch then goes to my APs and all my other devices. And so our VRRHA is the LAN untagged LAN network. Here I could have my VLAN 10, 172.31.254.0 or .1/24, and on this secondary router, I don't do anything. It's the exact same. So all my VLANs are going to be the exact same. If I could have 200 VLANs on this, and they're all going to stay the same. The only thing that matters is the heartbeat, the interface of the untagged LAN, and the heartbeat, which happens on the untagged LAN. And then the VIP is the default gateway of the untagged LAN. All my VLANs and my WANs and all my other settings are the same. And to configure it, program your master router first. Just program it, get it all set up how you want it, and then set the interface to 192.168.1.2 or whatever IP address you want to. Then all you do is go to HA, turn it on, and set your IP address here to 192.168.150.1 in this particular case. So in my network settings, untagged, that changes to 192.168.50.2. Set it to the master. Then on the secondary unit, I would choose slave, put in my master IP address, and put in the serial number of my master IP. And this one would be 192.168.150.3. And I'd put in the serial number, and they're going to sync up. And that's it. Super easy. And it's just on the LAN, the untagged LAN. All your other VLANs and all your WANs, none of that matters outside of the untagged LAN. And the easiest way to do it is configure your master, save the config file, go to your slave, load the config file, change the untagged LAN to .3 or .2, and then go to HA, choose slave, put in the default gateway and the serial number, boom, done. Really, really, really easy. HA is, and you can do this on all Peplink routers. The inbound rule, Sean Nemo, 2 megabits fully consumed. Does it drop excess? I drew my Visio images myself. Yeah, we spent a lot of time. Yeah, we built all our own Visio images. So I have all my own routers and everything I use for drawing. Okay, and so availability radius server is used for 802.1x and router authentication, and so for Wi-Fi and LAN now with 8.4.1. And so you put in your radius, your accounting server and your authentication server, and then you can apply that to your port settings and your Wi-Fi's. There's your 802.1x authentication right there. And you can enable that and then choose your servers. Certificate manager, it's the same thing as in control. It's just local service forwarding and service pass-through. Service forwarding allows you to forward services. So you can do SMTP service. So if you have like a smart host, which back in the old days, on your carriers, you can do SNMP forwarding, web proxy forwarding, DNS forwarding, and custom service forwarding. Service pass-through. This allows us to do service pass-through. Like if you're doing ALG or SIP, you can go to compatibility mode. So you have one-way audio and you're using SIP, change it to compatibility mode. If you're using Cisco Call Manager, you want to be on standard mode. We have H323, FTP, TFTP, and IPsec NAT-T. IPsec NAT-T is interesting. If you have NAT-T enabled and you are wondering why your IPsec tunnels got your WAN and not your SpeedFusion, you have to turn this off. IPsec NAT-T basically it's service pass-through. It kind of just passes that up your WAN connections, and it won't route that traffic out SpeedFusion, allowing you to SpeedFusion IPsec tunnels. IPsec tunnels just got your interfaces, and they always got like cell 1 or something. So if you want your IPsec to follow your outbound policy rules, you have to turn off pass-through for IPsec. GPS forwarding. is really, really popular with our first responders because they need to send their GPS to the CAD system. We support tons and tons and tons. I've never hit a limit. I'm sure there is a limit, but I've never hit it. You can basically forward the GPS location of this router to a lot of destinations. We support NEMA and TIAP, and then you can support the different sentence type, so either NEMA or TIAP, and then you can put in your vehicle ID, vehicle 10 or vehicle 20, and then you can send that to your destinations. Something new with 8.4 is GPS receiver. You can now actually receive GPS signals. So if you have another router that's providing you GPS and you want to receive that GPS and use it on this router, you can actually act as a GPS receiver now, which is kind of cool. Serial port, if some of our routers have a serial port, you can actually enable that serial port and then use it for out-of-band management, like accessing like a Cisco switch or other RS-232 device, and that gives you console access to that device. GPIO is used for ignition sensing, so you can do ignition sensing, which basically acts as a power button. So you have in your vehicle, you have your ignition that when you turn on, 12 volt turns on, and you have your battery. That's your constant 12 volt. So you plug your power into the 12 volt that's always on. Then you plug the ignition sense, the GPIO, into a 12 volt that turns on with your power. The router then will say, when I turn on my vehicle, turn on the router. And when I turn off the vehicle, stay on for a period, X number of seconds. So 60 minutes, 30 minutes, whatever you want. So I'm driving around, go to Starbucks, turn off the car. The router stays on. Go into Starbucks, get my coffee, go back out, turn on the car. The router stays on. So I'm not waiting for the router to boot up as I go from short stops. But I go home at night, turn off the vehicle, go inside. After 30 minutes, instead of killing my battery, the router shuts off. Network time protocol server. Peplink actually has a network time protocol server built right into our routers. So you can turn that on and the router becomes an NTP server locally, and it actually will sync with GPS. So pretty cool there. Grouped networks. We talked about group networks in control. It's the same here as it is in control. You can just add group networks, and then you can use those group networks in outbound policies and firewall rules. Remote SIM management is actually how you configure the SIM injector. And so if you want to use the SIM injector, you do have to configure it. And I do have a YouTube video on setting up the SIM injector, once again, at Peplink University, so you can watch that. SIM toolkit, this is a test question. SIM toolkit lets you run actions against a SIM card. So you have cellular 1 and 2. You have tool, I can do either SMS or USSD. So there's a question like, can you if I want to reload my SIM card via USSD codes, I can put that code right here. I can also go to SMS and I can retrieve SMS messages. So if I get a text message to this number, I can actually receive those text messages. Like if it says, hey, there's a 6-digit code sent to you, that cell phone number, I can actually receive those SMS right here. I can't send SMS, but I can receive them. And then I can send USSD commands. So this is good for like reloading or querying. Like if you have a prepaid SIM, like I said, if you're trying to figure out how many gigabytes you have left and things like that. No, my Visio stencils are mine. You can email me if you'd like. But they're like literally my artist drew them. So they're not on peplink.com. Somebody asked what happens if 192.168.1.4 fails. If the switch fails, then they both routers, if there's nothing on the LAN, would actually go into a standby state. So you'd want to have some sort of like, multiple switches or something like that. But if the switch fails, that's keeping the two routers up and there's only no LANs, they both go into what's called a slave isolated state. So if you ever see that, in HA, if you see the LCD says slave isolated, that means it's not detecting anything on the LAN. So there's no LAN, it just assumes there's nothing downstream. So it goes into an isolated state. So if you have two routers going into the same switch and that switch fails, the two routers will go into what's called slave isolated. They're both thinking there's nothing there. AP controller. We talked about the AP controller a lot during the AP section, so I'm not going to really review it again because it's already there. But you have your SSIDs. You can create SSIDs. Wireless meshing. One thing I will say about it real fast is wireless meshing. You can configure in control or here. if you set up meshing, you can do 2.45 or both, which will auto mesh based on whatever's best 2.45. You give it a mesh ID like PU mesh, and then you give it a password 1, 2, 3, 4, 5, 6, 7, 8, 9, 0. Hit save. Once you create a mesh profile or mesh network configuration, you have to go to your settings and choose the mesh to be used for, because remember we support multiple profiles, and those profiles can be assigned to APs. We have a lot of customers that complain, oh, I set up meshing and it doesn't work. You have to assign the mesh to a profile. Now, if you do this in control, Wi-Fi, group-wide settings, nope, radio settings. I can see right here, Wi-Fi mesh. I can add a mesh, PU mesh, 2.45. The both option isn't available yet in control. Pre-shared key. Hit OK. And then all devices. Save. Should be able to choose all devices, PU mesh. There we go. And save. So you create the mesh ID, then you can assign which devices, which profile gets the mesh network. And so you might have a whole bunch of different APs and only want a group of those called mesh 1 to get a certain profile. And then you might have another group of them and the same group that's mesh 2. And so you could create a mesh 1 tag, a mesh 2 tag, and then apply these different mesh profiles to the different tags if you want to. So then I can delete that and delete that. This is way easier to configure than trying to manage a whole bunch of APs and router settings on the local device. Then on info, you can see the status of your APs and your controller. And so there's the native one built in right there. You can see your wireless clients, the wireless SSIDs. You can see the status of your mesh or WDS network right here. So if you do create that mesh network, you can see it right there. So I'm trying to do this and watch. In order for GPS forwarding or GPS time, you do have to have a GPS antenna connected. And if you find that your GPS isn't working, it's most likely because the GPS can't see it, like put it next to a window or something. Like GPS in here is not going to work well, but if I moved it next to the window, like you saw, it was saying like 11 miles an hour, it's going to get more accurate. Okay, and then our system settings. So we can go into system settings. Here we configure all of our device system management. Remember in control, device system management. So there are system settings, firmware, time, schedule, email settings, event logging, SNMP, SMS control. Here's your SMS controls again. So we can pull this up, an ADEM SMS control, and you can actually assign a password and you can text commands to the router and reboot it or configure the SSL. So if you have a SIM card with a phone number, you can enable SMS control, whitelist your cell phone number, and then you can text and reboot your router or text and configure. So there might be a signal that's good enough to receive an SMS, but not a signal that's good enough to remote web admin. So you can actually enable SMS control and then reboot or configure parts of the router via SMS. You can text back and forth with your router. That's really cool. In control, you can pull up in control, and then you can either disable in control right there. So if you're an anti-cloud person, you can turn off in control, or you can restrict it to status reporting only. So hey, report, but only give me the status. I don't want anything else going there. Or if you have a privately hosted in control, you can check this and put in the URL of your private in control. Configuration, you can back up and restore your configurations right here. Feature add-on, if you're not connected to in control and you buy a feature and you need to activate it, you can click it here. If you buy a feature anywhere else, it's going to be pushed via in control. Reboot, Peplink supports two firmwares. So if you're using your router and you update the firmware and it's not good, you can reboot back to the previous firmware. Just hit reboot and it'll reboot you back to that previous firmware configuration. Yes. Clay asked if you can put different geofences per device. You can create lots of geofences and attach those by tag. So if you had 10 devices, you could do device 1, device 2, device 3, device 4, all the way to 10, and you could create 10 geofences. It's just based on tag, and you can assign as many tags as you want. If I have bonded cellular to make 30 megabit circuit and I do 2 hops over mesh to get to a different room, can I output mesh? Okay, so meshing, there, we talked about degradation and performance. But you gotta remember, there's LAN performance. I'm in a gigabit Ethernet. Well, if that gigabit Ethernet only has a 100 megabit internet, I still get 100 megabits. And if I cut my gigabit Ethernet in half, that's 500 megs. That's more than 100 megs. So if I have a 30 megabits per second circuit and I'm linking at 1 gigabit per second on Wi-Fi 5, and I drop that out down to 500 megs, I'm hopping down to meshing, I still have 500 megs of internet or LAN, which would be more than my 300 megabit circuit. But if you hopped again, you'd be at 250 megs, which would then be less than your 300 meg circuit. Hopefully that makes sense. If 10 megabits fully consumed, does it drop the excess or use? Randy asked about QoS. I apologize, I missed that a while ago. If the 10 megabits is fully consumed, does it drop the excess or use the failure? It doesn't. What you're doing is you're adding a QoS of 10 megs to that streaming protocol, which will prioritize it above other ones. So if you're running fully congested, it's going to try to give you the best of the best it can of that 10 megabits per second. And then, yeah, at that point, you would sacrifice if there isn't 10 megabits to even allow. Somebody asked me about my inbound rules. I never actually applied those firewall rules. I never clicked the save changes. That's why I kept giving me a warning message in control. That's why all mine were allow, because I never actually applied those. I didn't want to, hold on a second. Bulk DNS for cellular. Okay, that one I already did. Okay, there we go. Sorry. I was just trying to go through the questions, make sure I didn't get too far behind. So you can reboot to multiple profiles. This is also important if you're playing around with beta firmware. And here I did that. You see, I'm running 8.1 5452 and then 8.41 5474. Those are both beta firmwares. What I should have done is rebooted and then updated again and rebooted and updated again. Because if something does go wrong with this beta firmware, I can only revert back to that beta, the previous beta. I can't go back to the latest stable in a reboot mode. So when you update, like if I booted into this firmware 1, then updated, firmware 1 would stay 5452, and then the next version would be updated there. So it's kind of, so if I update twice, like if I update from this one, the next update is going to override 5452 and keep 5474 because the running firmware is 5474. And so I'm going to override 5452 when I do the next firmware update. Then you have tools like ping and traceroute and wake on LAN and WAN analysis, which we'll talk about WAN analysis when I do the troubleshooting steps. So I'm not going to do it here. And then we have our storage manager and our package manager. So once again, the BR2, the MBX, a lot of our routers support edge compute capabilities like Docker and application. And so here's where you can provision how much storage is allocated for the various capabilities like application and Docker and or KVM if you're using KVM capabilities. And then the package manager is for lets you see your packages that you've loaded in Docker, which we don't have any, so they're not going to be there. And the status page. Oh, yes, and we have 10 minutes left, so I'll be able to finish this fully and then move on. So we have the status page. Status page is going to give you your device capabilities. So it's going to let you know what firmware you're running, what SpeedFusion firmware you're running, what modem support you're running, and you can click that to watch it. And you can control managed features, so you can see what features are being managed by InControl. Runtime, download a diagnostic report, your MAC addresses of your different sessions, then go to Ethernet ports. And I can see my Ethernet ports and if anything's plugged into them. And this is, by the way, really useful because sometimes people will plug like a LAN into a WAN and they can't get an IP address. And I'll be like, oh, look, can you move that over one? And they go, oh, there it is. Active sessions is a great troubleshooting to make sure your outbound policies are working. So if I go to search, you can see right here, I've got my phone TCP, and it's using Office 365 and SSL, and it's going over WAN smoothing because those are connecting to my Office 365, which is my WAN smoothing protocol. So I can see my source and destination, what services is, and what interface it's using. So when I create an outbound policy and I want to see if it's working, I can go to status active sessions and see if my traffic is following those protocols I set up. And so you have your outbound, your inbound, and your transit, which is your internal. Client list will show you a list of all the clients on the network. My phone should show up. There you go. There it is. OSPF and RIP, it's going to be your status. It's going to show you learned networks. You can see 172.16.248 is being remote. That's probably the LAN of my hub device. BGP will show you BGP status right here. SpeedFusion will show you SpeedFusion status. So there's my SpeedFusion statuses, and there's my connection and my learned route. Serial is your serial status, which I have nothing plugged in, so it's not there. And then your event log, which gets dumped up to in control. But here it is. You have your device, your DHCP, your firewall, and your SpeedFusion event log. So you have IPsec, it'll show up here. So when you turn on event logging, like I turned on event logging on DHCP for my guest network. So if I connect to my guest network, it would show up here. The firewall, I've enabled event logging, so it's going anything that triggers those events will show up there. And then SpeedFusion, you can see my events are showing up right there. WAN quality is very similar to the WAN quality reports that you get in control. It allows you to see the quality data for the last, I believe it's 60 minutes. And you can kind of see that information right there. And then real-time, hourly, and daily and monthly usage reports are right here. So you can see there's your real-time, hourly, daily, and monthly. So even if you're not using in control, you get some baseline usage reports built right into the router. Whew, that was a lot. But we got most of the UI covered. That is a lot of information in a very little amount of time. So one last thing I'm going to show you. Oh yes, okay. Is if you go to the address bar, you see this index.cgi. You can change index to support.cgi, and support.cgi will give us a secret menu that will let you get some things if we're experimenting or we're testing a new feature and we don't know where to put in the GUI yet, or there's features that we just don't have a place for in the GUI, they go to support.cgi. So in support.cgi, I can see my LAN and Ethernet details. So there's my LAN and Ethernet, my drop packets, my interface settings, whether or not they're up and down. I can configure my speed, my interface speeds. I can see my remote assistance is connected and it'll turn off automatically. I can download diagnostic report. I can run a network capture. The network capture is limited to the 20 megabytes or the storage available of the router. So it's 20 megabytes or the storage available of the router. Or you can do a remote capture and send the network capture to another IP address, like a listening machine. I can check for cellular module firmware updates. I can enable watchdog support. There's a lot of stuff. I can do a health check failure simulation, which I'll teach you how to do when we do the module 4. I mean, there's a lot of cool features in here that get added. Yeah, there's your net flow right there. Fusion SIM agent, Fusion SIM proxy, which is a lot related to the SIM injector, DPI support, Wi-Fi, WAN, band, SSID steering. So you have that capability. So there's a lot of features in the support.cgi that isn't necessarily built into the router directly. Okay, so let me see. Dynamic weighted bonding, traffic steering, how to cut off latency. Oh, cut off latency. That's a good one. Thank you. Okay, so in SpeedFusion, I forgot to show you this. See, that's why we have the cheat sheet there. When you're configuring a SpeedFusion profile, whether it's SpeedFusion Connect or SpeedFusion, if you click on the profiles, there's a question mark right here under WAN connection priority. And you can click here to enable asymmetric connection, connection mapping, and customize cutoff latency, and suspension time. So these are different mechanisms in which the router will use each of the WAN circuits under the tunnel. So I can say I have two T-Mobile SIMs, and I want T-Mobile 1 to be download only and T-Mobile 2 to be upload only. Literally, I can have two T-Mobile SIMs, both on band 25, both SA, one SIM card dedicated to upload and one SIM card dedicated to download. So I can do asymmetric or symmetric priorities. Let's say WAN 1 is a point-to-point private network. It has no access to the internet. I can tell WAN 1 to talk to WAN 1 on the remote router and can bond to a private network with a 5G network. So if I have an MPLS circuit that's layer 2, I can actually bond. So I could tell the remote routers to talk only on WAN 1 to each other. So WAN 1 to WAN 1. And then my cellular connections and my fiber and my other public internet addresses can talk many to many. This is going to allow me to bond with MPLS or a private Wi-Fi or a private fiber cable between two routers, however you want to see it, and offer bonding of private networks by restricting which connection it can talk to. Cutoff latency says, what is my threshold for latency? If I'm sensitive to latency and I say, I don't want my latency to go above 110 megabits milliseconds, I can program 110 milliseconds there. And at 110 milliseconds, it's going to stop using that circuit. It's going to assume that there's something wrong. Then suspension time after packet loss. Suspension time after packet loss will suspend the circuit if it detects packet loss within a certain milliseconds of time. Forwarding, enable add-on feature, ignition, sync, net mapping. Perfect. Okay, awesome. And we are done. And I'm going to do synergy mode at the next session. I am so grateful that so many of you stuck around for the majority of this call. This was a lot of information, and the 4 hours, I know some of you are in different countries and it's way past dinner time, but thank you so much for attending. And we will start on the web admin synergy mode starting the second Tuesday of February. And I look forward to we're demoing this next week, in February, and we'll continue from there. And thank you so much, and have a great day.